growing up to build a country in simplicity. Faculty of Mathematics and Natural Science, Universitas Negeri Semarang, has become a home for the development of civilization. A place for various student backgrounds to mingle and a witness to the birth of innovation. No exception for talents who have grown into the spirit of work. Since 1965, the Faculty of Mathematics and Natural Science, Universitas Negeri Semarang, has proven itself to maintain the quality of higher education. Side by side, exchanging insights, opening horizons, providing the best experience and high-quality education.
This is our place, exchanging knowledge from discussions rooms on campus. Deep in the root to bring creativity and innovations endlessly. We always take steps creating high-quality products. Get in touch with the nature, running, welcoming dreams that await.
High aspirations to build a nation are not enough to teach us dreams, but there needs to be real action in reforming.
I feel comfortable to studying here. Friendliness, novelty, religion, innovation, and creativity are really seen in FMIPA UNES.
Here, I can not only deepen the knowledge that I have understood, but I can also broaden horizons in the world of science.
We continue to grow to be the best faculty in education, research, and technology. Collecting one by one series of knowledge. Delivering FMIPA graduates to be a highly dedicated future generation.
The Faculty of Mathematics and Natural Sciences, Universitas Negeri Semarang provided experience, knowledge, and support that brought me to the point where I am now.
Changes and demands of today's science and technology environment increasing dynamically, requiring maturity of knowledge and skills. I was guided by my lectures to develop curiosity and have a systematic way of thinking in dealing with various situations.
Academic adventures presented by the Faculty of Mathematics and Natural Science UNES not only able to meet the changing needs of the environment, but also the academic passion that the connoisseurs will always miss.
Our faculty enriches the best experiences for students guided by noble conservation value. We encourage the students to become talented people who grow brilliantly to create innovation and bring change to Indonesia and the world.
This is where the steps to realizing aspirations begin. Work, innovate, shining bright for the advanced Indonesia.
Welcome to our home.
Let's go for Indonesia.
FMIPA UNES, signing faculty for advanced Indonesia.
Good morning, dear all participants. I'd like to share the virtual conference rules of ICMSE 2021. The first is use virtual background provided by the committee, and then rename your Zoom ID with institution name and your name. Mute your microphone during the plenary session presentation, and you can unmute your microphone in the Q&A session. Please write the questions in English in the chat box and mention the addressee or for whom the question is for. And please turn your camera on during the conference. And the last is fill in the attendance list, which will be provided in the middle of event. Ladies and gentlemen, have a good day and enjoy the conference.
Akan ada masa di mana kita menjalin rasa manusia dengan semesta. Mendaki ke puncak tertinggi, menggapai tujuan dengan kerja keras dan strategi. Perjalanan mengajarkan banyak arti dalam setiap langkah yang terlewati. Bercerita lewat asa untuk terus dijaga.
Manusia sejatinya berencana, menata cita-cita dalam bingkai rencana. Percaya bahwa keindahan tercipta bukan instan, melainkan lewat prinsip dan pedoman. Kreativitas dan imajinasi saling berkolaborasi, mengasah naluri, menjamah potensi. Tak akan bertemu ujung untuk apa yang kami kejar. Tak akan tercipta rasa tanpa belajar. Apa yang kami lakukan berawal dari sebuah ilmu yang kami emban di rumah peradaban, Universitas Negeri Semarang.
Kemajuan kita sebagai bangsa tidak bisa lebih cepat daripada kemajuan kita dalam pendidikan. Pikiran dan wawasan menjadi sumber daya fundamental.
Di sini saya belajar banyak hal, seperti mempertajam kecerdasan, memperkukuh kemauan, dan memperhalus perasaan.
Pendidikan adalah senjata paling ampuh untuk mengubah dunia, termasuk Indonesia. Berangkat dari mana? Ya dari diri kita sendiri.
Inilah Rumah Ilmu Pengembang Peradaban, tempat tunas penuh talenta tumbuh bermekaran dalam kasih sepenuh hati, bertumbuh menemu arti. UNES Gemilang untuk Indonesia Maju.
Kegemilangan memandu UNES dalam melahirkan generasi berkarakter dan berprestasi, agar tunas muda Indonesia bertumbuh, menemukan peran dan makna demi kejayaan Indonesia dalam peradaban dunia.
Setia mengawal semangat perubahan demi kemajuan bangsa dan peradaban, sebab kami percaya niat baik saja tak cukup. Denyut inovasi harus terus berdegup. Arum luhuring pawiyatan ing astoniro, semangat ini berdiam di hati, terpatri di jiwa kami.
Selamat datang di Universitas Negeri Semarang.
Gemilang untuk Indonesia Maju.
Selamat datang di Universitas Negeri Semarang. Gemilang untuk Indonesia Maju.
Good morning, dear all participants. I'd like to share the virtual conference rules of ICMSE 2021. The first is use virtual background provided by the committee, and then rename your Zoom ID with institution name and your name. Mute your microphone during the plenary session presentation, and you can unmute your microphone in the Q&A session. Please write the questions in English in the chat box and mention the addressee or for whom the question is for. and please turn your camera on during the conference. And the last is fill in the attendance list, which will be provided in the middle of event. Ladies and gentlemen, have a good day and enjoy the conference. Good morning, dear all participants. I'd like to share the virtual conference rules of ICMSE 2021. The first is use virtual background provided by the committee, and then rename your Zoom ID with institution name and your name. Mute your microphone during the plenary session presentation, and you can unmute your microphone in the Q&A session. Please write the questions in English in the chat box and mention the addressee or for whom the question is for. And please turn your camera on during the conference. And the last is fill in the attendance list, which will be provided in the middle of event. Ladies and gentlemen, have a good day and enjoy the conference. Good morning, dear all participants. I'd like to share the virtual conference rules of ICMSE 2021. The first is use virtual background provided by the committee, and then rename your Zoom ID with institution name and your name. Mute your microphone during the plenary session presentation, and you can unmute your microphone in the Q&A session. Please write the questions in English in the chat box and mention the addressee or for whom the question is for. And please turn your camera on during the conference. And the last is fill in the attendance list, which will be provided in the middle of event. Ladies and gentlemen, have a good day and enjoy the conference.
Ladies and gentlemen, let me introduce the vision of UNES to be a conservation inside university with international reputation. UNES has spirit as a house of knowledge. Here, we always build our campus to develop civilization in producing quality of human resources in various fields in order to make better life. Next slide. Ladies and gentlemen, I would like to bring your attention to our milestone UNES start from 2020 up to 2024. UNES is the Teaching Institute of Higher Education, or here commonly called LPTK. So, we are having two principal aims, growing as a research university and teaching university. UNES, as a house of knowledge, we are growing and continuing to innovative in any sectors, including in developing research innovation. We can see here that the number of research publications is rising every year. Next slide. By having this at ICMSE, we do hope the scopus publication of UNES will increase. So, I really appreciate to all community, and the Dean Faculty of Mathematics and Natural Sciences who having cooperation with AIP conference proceeding JPII, Bioscientifica, Creano, SJI, and JPFE journals, and prepare the reputable output of this at ICMSE. Ladies and gentlemen, as a rector, I'm so happy this at ICMSE rise and update issue in this conference by having a great theme, opportunities and challenge for research and innovation in mathematics, science, and education in post-pandemic era. This theme was chosen to overshadow the field of mathematics, physics, chemistry, biology, computer science, and science and mathematics education. Next slide. This at ICMSE is one of the great international seminars in the ASEAN. In this year, we have some registered co-hosts. They are University Teknologi Mara, Malaysia, and AMLI, Asosiasi MIPA LPTK Indonesia. So, thanks to Universitas Pendidikan Indonesia, Universitas Negeri Yogyakarta, Universitas Negeri Malang, Universitas Negeri Jakarta, Universitas Negeri Medan, Universitas Negeri Padang, Universitas Negeri Manado, Universitas Negeri Makassar, Universitas Pendidikan Ganesha, Universitas Negeri Gorontalo, and Universitas Negeri Surabaya. It means Faculty of Mathematics and Natural Sciences UNES fully support the vision of UNES in reaching networking and international reputation. Again, thanks to all the committee. Ladies and gentlemen, all of us understand that the change happened in very existence line. So it is important for ensuring the sectors of technology for education in this era. Ladies and gentlemen, finally, it is expected this at ICMSE can produce significant and valuable ideas and also design the first possible contribution to the education system both in Indonesia and the world. I hope we can continuously build and develop collaboration with foreign institutions to improve human resources and bring out goodness to the world. The poem dari Padang menuju Pangkajene, singgah sebentar di Pekalongan. Selamat dan sukses ICMSE, membangun keilmuan merekat persahabatan. With this remark, I declare this 8th International Conference on Mathematics, Science and Education, ICMSE, officially open, and wish you all faithful deliberation. Thank you very much for your attention. Enjoy this at ICMSE. Assalamualaikum warahmatullahi wabarakatuh.
Mantap mantornya. Mantornya mantap Pak Satu.
Thank you for Vice Rector of Academic Affairs, and also welcome to Rector of Universitas Negeri Semarang, and thank you, sir. Ladies and gentlemen, before starting the plenary session, let's have a photo session. Now, I would like to invite you to on cam and turn your camera on. I will count into 3. After 3, we will start to capture your picture. 1, 2, 3. Please be ready. Slide number 1. Slide number 2. Slide number 3. Slide number 4. And slide number 5. Thank you. Ladies and gentlemen, this is the very moment that we have been waiting for, plenary session. The first plenary session will be from the honorable speakers, Dr. Yasmilo Hasako from Thailand, Professor Cher Ping Lim from Hong Kong, and Eza Syuhada Sazali, PhD, from Malaysia. And the presentation will be guided by Rifa Atunisa, PhD. Before we start the first session, I'd like to present the profile of the moderator. Rifa Atunisa, PhD, is the lecturer of Faculty of Mathematics and Natural Sciences, Universitas Negeri Semarang. She finished her bachelor degree and in Institute Pertanian Bogor, and master and doctoral degree in Hokkaido University, Japan. Her major and research interest is in environmental science field. For moderator, time is all yours.
box. And if you wish asking question to the specific speakers, please mention the name of the speakers on your question. So let's begin. Our first speaker in our list is Eza Suhada binti Sazali, PhD. May I briefly introduce to you our first keynote speaker. Dr. Eza now is Assistant Dean and Senior Lecturer in Department of Physics, Faculty of Science, University Technology Malaysia in Malaysia. And she was graduated from Physics Department at University Technology Malaysia for bachelor degree and master, and got PhD in science also at University Technology Malaysia. Many publications had been published in many reputable journals, and now she will sharing with us her expert opinion about bioglass development. Dr. Eza, hello. Good morning. It's a great honor to us having you as a speaker in our conference. Dr. Eza, you have 25 minutes to deliver your presentation, and please.
Okay, thank you so much, Mrs. Chairman, for the kind introduction. I will share my screen first. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And very good morning to everyone, to organizers and also participants. I'm Eza Shwada Sazali. I'm from Faculty of Science, University Technology Malaysia. Today, I will present my talk entitled Future Promises of Bioglass. The concept of bioglass was originated in the late 1960s, but present demand for repairing bones and teeth damage is rapidly increasing. So in this talk, I'm going to demonstrate the kind of bioglass that we are making in our lab and how it will work for bone repair and also the state of the art of the bioglass. Before we use the bioglass, we must know the science knowledge of the bone and glass, okay, artificial glass. So therefore, let's go quickly look at the inner structure of bone and also our teeth. Okay, they have a lot of fiber, living tissues, and cellulose packing. And we know the bone is tissues. The bone tissue is a dense organic packing, which consists of mainly of collagen, and also the inorganic part consists of hydroxyapatite, HA. Okay, and the tooth enamel is the hardest and most mineralized substance of the body, which they consist of crystalline calcium phosphate, the major mineral, okay, in our teeth, and they have high strength because of the hydroxyapatite. Okay, so the structure of the HA, hydroxyapatite, is largely crystalline domain, but at the breakage it is disordered. So now let's look to our normal drinking glass. We know our normal drinking glass mainly is consists of silica, right? So both bone and our glass have almost the same structure. The question is, if a piece of bone is broken, is damaged, okay, can we replace the broken part using our drinking glass? The answer, of course, is no, because it is not biocompatible. We have to bring some kind of material that have strong structure exactly like our body, like our bone, like our teeth, that could match with our body in terms of the nature, the chemistry, the network, the morphology, the passivation, the bindings, okay, composition, mechanical strength, and many more. So the greatest potential for bone substitution is shown by material based on their hydroxyapatite. So here's come the bioglass. Okay, bioglass contain calcium, which when calcium is released to our body fluids, it will react with the phosphorus, and that is in our bloodstream and forming the hydroxyapatite. So this particular HA will form at the surface of the silicate-based bioglass and on its exposure to the body fluids. So bioglass, bioactive, is a bioactive material which is able to react inside a living being and promotes tissues regeneration. As we can see here, this is the difference of glass component between windows and also bioglass. For windows, okay, which is type 2, the cells face glass as a foreign body, but it's not harmful. Therefore, they isolate the glass implant with a fibrous capsule. But for bioglass, 45S5, S5, which was proposed by Prof. Larry Hench in 1969. Okay, it's much more interesting. The cells and body fluid have a strong interaction with the glass, so it is possible to stimulate their proliferation and to repair the tissues. We can also see the difference in the glass composition. Mainly, the windows consists highly on the silicate, but bioglass is only 45. But in terms of calcium and also sodium, windows have much lower composition. So the disorder of amorphous network contributes a higher dissolution rate compared to the crystalline ceramic. Therefore, the HA layers will form much more quicker on bioglass compared to ceramic. So whenever anything in our body reacts, they will go through the oxidation and the reduction process because it is in the water, in the aqueous solution, right? So we need some broken bond, which are some closed bond, and this is the structure that we propose, okay, the bioglass structure. Here there is a trade-off. Because our bond made of natural, mineral, and inorganic material, can we make a glass in laboratory which can be close as organic and inorganic material composition as our bone and teeth? So that is the question. Here we can see the unattained triangle. Okay, this is actually the ternary diagram for bioactive glass, which is depicted containing 6% wet percentage of phosphate oxide. If we look at this triangle, they are all oxides, right? And this is why the bond is becoming closer to our artificial bioglass. If we can make a glass whose composition characteristics are very close to our bone, so that means we can solve the problem. So this triangle telling us how close the compositional characteristic of bioglass can be closer to the real bone. From this triangle, we can see very high reactivity, state, okay? And then we can also see the region A, which has been reported as the gene activating, an important step in the ossification process. Okay, so this region also has the possibility to bond of the soft tissues. Okay, currently the present glass in the market has major problems. The first one in terms of the structural stability. This kind of glass is not very stable. For example, if we have an egg and we keep it for a few days, for example, it will get rotten. So similar goes to this kind of glass. Their chemical, after few months or years, they do not work. So they have unstable structure, which is low chemical durability. Okay. Next, the rate of hydroxyapatite also is very slow because the chemical structure is not stable. Okay, so they cannot do it permanently. So it can once again break and the fracture also can grow. But this bioglass that we try to propose is to bind the cracked surface by chemical process, hydroxyapatite, and play the role of repair. These present materials also, because of their slow HA, they have weakly bioactivity, which bioactivity is how quickly it can get activated once we put it in our system and starting the repairing process. And this promising bioglass will also can save the bioavailability, biocompatibility, and also the unstable problem. What is the problem scientists are facing all over the world to make this bioglass as the right implant? Some of the important problems that people have identified. For instance, we need to enhance the bioactivity. So the existing material exhibit low bioactivity. But in 2004, some previous researcher, they has found that by combining the sol gel method, conventional sol gel method, with supramolecular chemistry or surfactant, they prepare the mesoporous bioactive glass. So this particular mesoporous bioactive glass, they exhibit bioactivity very fast within only 4 hours instead of 3 days for conventional sol gel. Second, we need to optimize the porosity for the best repair or healing. Even the latest research has been reported by incorporate the surfactant, okay, will lead to highly ordered mesoporous bioactive glass, which will contribute 5 times on surface and porosity of the glass. And we also need to optimize we need to increase the strain, the mechanical properties. How we can combine the polymer polycaprolactane, PLA, and also polylactic acid, PLA and PCl, which might produce less hydrophobic construct, and at the same time, it can adjust the degradability of the sample. However, okay, when the sample have the high porosity, it can cause tuberculosis. So what we can do, we can introduce a few oxide that can reduce the bone length, okay, to increase the mechanical properties. Last one, we need to increase the rate of hydroxyapatite. Recently, borate and borosilicate-based bioglass get so much attention because their chemical durability reacts quickly and convert more complexity to hydroxyapatite compared to the present glass. So before we go in detail on the mesoporobactive glass, let's see the composition of bone tissues. We know bone is a well-organized connective tissue which is made from several building blocks. So it is composed 70% of inorganic phase and 30% of organic phase protein. So for inorganic phase, the bone enriched by the hydroxyapatite and collagen nanofiber. Okay, so the skeletal, okay, our skeletal system functions like a machine. So it is not surprising if it can be damaged, which we call it bone fracture. So when this bone has micro fracture, so can I put this particular bioglass in the form of paint or like glue so that the bone can be repaired, right? Exactly like the previous bone. So will it generating the tissue and structure? And that's where this research is aiming for, okay? In order to increase the human lifespan, especially for those who are facing with the huge or large segmental bone defect, okay, scientists have tried to take the challenge to try to find material that can repair the defect. So if we can see here, the first metallic materials successfully used during the 20th century, which they proposed stainless steel and cobalt chrome-based alloy. And then after several years, they found, several researchers found, they use the ceramic biomaterials, which commonly using the alumina, zirconia, and several porous ceramic. And in the late of 1960s, okay, Prof. Larry Hesch, he proposed a new material, which is called bioactive glass. And in 2004, as I mentioned just now, you and co-workers, they combined the conventional sol gel with the surfactant, okay, to prepare the mesoporous bioglass. So this is what we are aiming for. So mesoporous material, okay, we have the mesoporous material with nano-sized porosity, and we have bioactive glass. So if we combine both, okay, so we can get mesoporous bioactive glass. We can see here the microgram of conventional versus the with introduction of surfactant. They both have same amorphous atomic structure, but the additional part for the mesoporous bioactive glass, they have ordered mesoporous structure. This one actually successfully synthesized by EISA technique, evaporation induced self-assembly process, which is the modification of the conventional sol gel, and we introduce the supramolecular chemistry surfactant during the preparation. Okay, so how actually the surfactant works, okay? In easy way, surfactant is a molecule, okay, that has the capability of being hydrophobic in tail and hydrophilic in head. So what happens if we place this particular surfactant inside the solution of water? So in water, the hydrophobic tails will gather in the center, which we call it micelles, okay, which is the arrangement to limit the contact of hydrophobic into the water surrounding. So in order to get mesoporous silica, we use this surfactant and silica-based glass. So when we evaporating the solvent, which is ethanol, locally the concentration of water will be increased and also the surfactant. So higher concentration of water will attack the tetrahydroxysilane, which is soluble to produce silica, which is solid. So that is when they start to polymerize the silica around the micelles. So once we wash the surfactant, we will have the organized array of holes. So we get the good porosity, okay? So this is the representation of 3D printed mesoporous bioglass scaffold. So A is the different size and shape, and this one is different morphology. Okay, different size and also morphology. Okay, when bioglass is introduced to the body fluids will react with the glass, and the glass will start to dissolve, and the ions will release from the glass, and they will start the cell recruiting effect. So along with the material that acting like a scaffold. So how actually the mechanism? When the bioglass particle is subjected to the aqueous fluid, okay, it will immediately start to release ions. We can see here. Okay, when we introduce the fluid, it will release ions. So we know the for bioglass 45S5, as I mentioned just now, they have 4 main components: silica, sodium, phosphorus, and also calcium. So silica is the network former. The structure will hold the particulate together, and it will release, okay, immediately these ions. So this reaction will occur hours, days, okay, and eventually the solution will form hydroxycarbonate apatite here. Okay, so then the collagen protein will immediately absorb the silica layer because there is negatively charged layer, and the reaction will continue for days, weeks, and months until the particles are consumed and the bond left in the defect. Okay, so it can also stimulate the tissue regeneration, which the tissue will grow again in the defect. Okay? And this is actually also this the explanation of the mechanism, how actually the bioglass integrate with the bone. And this is the scheme of apatite formation on the surface of bioactive glass. Okay, how about the production and the comparison between those techniques? In the last decades, countless types of glass has been synthesized, and studies by changing the former, the modifier, the molar ratio, okay, because we want to get the optimized glass, okay, to improve the capability. So bioglass with the host of silicate or borosilicate glass can be fabricated by 2 techniques: melt quenching, also sol gel. But as I said, the traditional sol gel is the normal sol gel, but they propose using the EISA, which they introduced the surfactant. Okay, we can see the difference in terms of the surface area using the EISA process. They have the highest or larger surface area, and also the pore volume as well, and they get the pore size, mesoporous. Okay, and the mesostructure is also ordered, and the best part is the bioactivity is only took for 4 hours instead of 3 days from the conventional sol gel. So during the preparations, there are a lot of parameters that we need to control until we get the best one. The mesoporous bioglass is prepared by 3 basic sol gel technique, which is sol mixing, sol forming, and gel drying and heat treatment. It started by stirring all the raw materials, okay, for 7 hours under fume hood at room temperature, and then we form the soil. So once we get the soil under EISA process, okay, we leave it for 24 hours for 1 day at 35 degrees Celsius, and then we get the gel, which is and then we left for aging for 1 day under fume hood at 60 degrees Celsius, and then the gel monolith will be dried, okay, and then will be dried under different calcination condition, which is we set from 400 to 700 degrees Celsius for 6 hours, and we get the white solid form, which is the mesoporous bioglass. So these are some of the several steps in the techniques to get the structural morphology. So we mix the process for 7 hours, and then the EISA process for 24 hours, okay, and the aging process, calcination process, different condition, because we want to get the most optimum glass samples. And yeah, this is the proposed mesoporous borosilicate bioactive glass. So in order to produce effective bond graft, the mesoporous bioglass powder is needed to build into a scaffold form, because we want to try to put it in the defect. So simple preparation of PCl and PLA polymer scaffold make it a great choice to get the 3D scaffold. So first step, we mix all the material and stir it in for 1 hour Okay, and then the samples were taken out and pour it, the solution is poured into sodium chloride with macrostructure. Then the samples were taken out and dried at the room temperature for 48 hours. And then we remove the solvent, and then the sodium chloride will leach out, okay, by immersing the sample with the ionized water. And then after the leaching, drying process, and we get the scaffold, okay, the 3D scaffold. This is the visual look of the bioglass. Glass, as you can see here, glass sample before and after mill. Okay, so we can see the difference in we set different calcination temperature. So the light color might be due to the calcination condition, which we may not have been given time for the decomposition of the organic micelles. So, and the progressive of melting of the gel during the temperature rise must have fused. So the pores or densified the network, thus trapping the micelle within them. And if we can see here, the black color appears in the sample with calcination temperature at around 600 and 700 degrees Celsius, might be due to the carbonation process which occur during the temperature rising. Okay, now we go to this particular part. Whenever our bone breaks, right, we go to the doctor and we do X-ray to know where exactly the bone breakage, and then only the doctor will decide to do the plaster. So whenever our bone is break, now we will use our implant, for example. So how do we sure that this implant will repair the bone? So first, we need to know the structure of the repairing materials, right? It must be biocompatible. So, and that what X-ray is, we want to know the electron density map of the material. So from this pattern, okay, XRD pattern, since there are no crystalline peak, so yes, we can end up with the red class, okay, the amorphous structure. Okay, before we use the bioglass for our bone and teeth, we have to make sure the microstructure of the glass fits with the microstructure of the bone tissues and collagen. So this test measurement of porosity tells us, yes, we are very close, so go ahead. Right, so we have here to test the nitrogen absorption desorption isotope of samples and the BGH pore size distribution curve. Okay, from here we can see all samples have type 4 isotopes, which is mesoporous material, and they have the same hysteresis loop, which is type 1, which shows the hexagonal P6mm mesoporous. But we can see here a sample with 700 degrees Celsius calcination temperature have irregular pore structure. Okay, and the sharp peak shows here, okay, shows a good mesopore structure. Then if we see the BGH pore size distribution curve, okay, we can say that the pore size is very small, is very narrow size, from 2 to 2.9, the range. And we can say that calcination temperature at 600 degrees Celsius shows the highest BET surface and one of the most highest pore volume. So how about the inner structure and bonding? As I told you in the beginning that oxygen and ion concentration play a very important part for the repair because everything in the aqueous media. So the question is, where from this ion will come? It will definitely will come from the chemical bond breakage. So FTIR is done to indicate how many such bond is available and what way they are going to participate for the repairing process. And the consistencies of this FTIR spectra telling us this glass is reproducible, so we can make large scale of for the industry. So this is the FTIR spectra. Okay, we can see they have the consistency in all shapes. Okay, and then they got 10 peaks. We can see as well. Some of the peak has been shifted to higher wave number, which indicates the change in the calcination temperature can change the vibration mode. And we have the moderate band at 1600. Also the carbonate band. Okay. So in the previous, we have seen the bonding, but now we need to know which bond can really we use to exploit this kind of repair. So from the figure, we do the convolutions FTIR spectra. So we have two vibration mode that can be analyzed whether our glass have potential for bond graft or not. Okay, as we replot the ratio of this particular mode, okay, we have the ratio is greater than 1, which shows the efficient ion exchange and faster dissolution of silica and formation of new bond. And if we see the index, okay, from the index of the samples, okay, we can see the glass content of carbon increase with the increase of calcination temperature, and the present carbon may affect the bioactivity of glass. So as the conclusions, mesoporous borosilicate biotic glass with different calcination temperature have been prepared using the EISA method. The influence of calcination temperature in mesoporous borosilicate bioglass can be observed clearly on the morphology and structural. The result from nitrogen adsorption desorption isotherms reveal that all glasses possess high specific surface area and porous volume. They are influenced by different calcination temperature, and the increasing of calcination temperature decrease of the perturbation of the silica network is found, and the variation also can be found, okay, the pattern. So with that, I have finished my presentation. I would like to take this opportunity to thank to the organizer for inviting me for this talk. And I hope that you guys, every one of you enjoyed my talk. So I would like to acknowledge, to thank to my research group, Advanced Optical Material Research Group in Department of Physics, Faculty of Science, UTM, our Material Laboratory, UTM, of course, Prof. Dr. Sip Krishna Goshal, and also my students, Siti Halija, Puzi Negrati, and also Nadia Shafira Ramli. Thank you.
Thank you very much, Dr. Eza, for that very insightful presentation. And considering the importance of the bioglass in the medical world, research and improvement will definitely continue to be carried out. Yeah, that is very interesting. And we will continue discuss later, Dr. Eza. And moving forward, we will listen the next keynote speaker. I will invite Dr. Yasmi Lohasakul. Dr. Yasmi now is a head of biology program and also head of the biological technology and innovation program in the Faculty of Science, Technology, and Agriculture at Yala Rajabat University in Thailand. Her expertise are bioprocess, fermentation technology, microbial products, waste utilization, compost, biofuel, also in a biocatalyst. And also many publications have been published in many reputable journals. And now she will present the topic of the potential use of wastewater for the production of biofuels. Dr. Yasmi, hello. Good morning. Yeah.
Good morning. Yes, can you hear me clearly?
Yeah, yes, clear.
Okay, let me share.
We are
my
pleased
slide.
having you as a speaker in our conference today, Dr. Yasmi. And Dr. Yasmi, you have 25 minutes also to deliver your presentation. And please.
Okay, thank you. Let's first let me share my slide. Okay. Okay. Assalamualaikum warahmatullahi wabarakatuh. Good morning from Thailand, and thank you everyone for coming. I'm Yasmi Lohasakul from Yala Rajabat University. First of all, I would like to thank you for inviting me to this conference and for giving me the opportunity to share my research as a keynote speaker. I appreciate it. And hopefully my presentation today will provide valuable information for you all. And today I'm delighted to be here to talk to you about the potential use of the palm oil meal wastewater for the production of biofuels in a bio refinery concept. Okay, you know that the palm oil has become a key ingredient in a whole host of device products we use daily, such as the detergent, lipstick, shampoo, chocolate, bread, ice cream, and biodiesel. And according to the data from the United States Department of the Agriculture, nearly 85% of the palm oil is produced in just 3 countries: Indonesia, Malaysia, and Thailand. Other major palm oil producers include Cambodia and Nigeria. Those all two produced less than 3 million tons last year. And during this operation, besides producing the crude palm oil, the industrial producer generate a lot of the solid waste and liquid waste. For the solid waste, such as the empty fruit branches, mesocarp fruit fiber, and palm kernel shells. And for the liquid waste, it's called palm oil meal effluents, or palm is in short. And by the way, with every 10% of the oil generated, approximately 90% of waste include the solid waste and liquid waste generated too. And as we know, both of them are considered as the major environmental pollution problem. For example, in the southern of the Thailand, there are nearly 49 registered palm oil processing plants with annual production capacity about the 400 to the 500 metric ton of the crude palm oil. And of these, around 17 of the plants use a wet process and present about 50% of the processed palm oil in local market share. For example, the palm oil industry in the Krabi, it generates overall wastewater around 0.57 cubic meter per tons of fresh fruit bunches. So the water pollution is a big problem. And we know that normally in the wastewater treatments, aerobic method or aerobic digestion and anaerobic digestion or anaerobic method can be applied to treat pomade or palm oil meal effluents. And usually, the current most applied treatment strategy of the pomade is fermentation through anaerobic digestion, which can produce the biogas. This is one of the biofuels. But the long retention time, low gas heating value, and no complete removal of the pollutant are considered as the main disadvantages associated with a sole and aerobic digestion only. And with the high efficiency for the conversion of the organic compound into the microbial biomass and carbon dioxide, and the microbiomass with contains a valuable organic matter and nutrients such as the nitrogen and phosphorus can therefore be useful as a fertilization or soil improver. So in our research, we try to alternative the conversion of the organic substrate in aerobic process into the microbial lipid, which can be used as the biodiesel feedstock and follow using an aerobic process for the biogas production. Actually, the process of the fermentation has stabilized under an aerobic condition. The pH will be take on a value of between 6.5 to 8. It's a neutral. But anyway, the pomade is typically acidic. For example, this is the pomade we use in this study. pH is 4.9. So how we can do it? We try to firstly by cultivate the oleaginous yeast that is not only to produce lipid, but also to stabilize the pH of pome. Because after cultivation of the yeast, the pH will be changed to almost neutral. So with a high organic compound in form of COD in the pome, we found that after the cultivation of yeast, we found around half of organic compound are consumed. So after that, we try to use a secondly produce the produce the biogas via the anaerobic digestion. So I would like to give you a little bit background information about the microbial lipid. The microbial lipid is produced from the oleaginous microorganism. So what is oleaginous microorganism? Oleaginous microorganisms that are microorganisms that can accumulate lipids more than 20% of their biomass, and that include some species of the bacteria, fungi, yeast, and microalgae. But among these oleaginous species, these are most favorable oleaginous microorganisms in terms of their fast growing like a bacteria, high cell density growth like a bacteria, high lipid content, and the lipid mainly composed of triglycerol containing a long chain fatty acid, which are similar to the vegetable oil. So in our study, previously we test many species, many strains of the oleaginous yeast. But among of the strain tested, we found that the Yarovia lipolytica STR5151 is the most attractive candidate because first, it is non-pathogenic yeast. It means it is safe for use. And secondly, it can accumulate lipid more than 30% and may increase up to 70% of its biomass. So which composed of a high triglycerol, and it can also produce a cell-bound lipase on either low-cost hydrophobic or hydrophilic substrate. And this is a colony of the Yarovia lipolytica STR5151 on the plate agar, and the yeast show the oval cell under the microscope. And so for this characteristic, it's expected that it can be possible to economically produce lipids and lipase by the yeast for biodiesel production by using pome as a fermentable substrate. So I need to give you some backgrounds, a little bit background information about the lipase enzyme. The lipase enzyme is the hydrolytic enzyme that can catalyze hydrolysis of the triglycerol into a free fatty acid and glycerol. And it can also esterify and trans-esterify free fatty acid or triglycerol into the biodiesel. And generally, lipase is divided into two classes, extracellular lipase and intracellular lipase, that is defined. So the cell-bound lipase is one of the intracellular lipase that is defined as the lipase bound on the cell surface. And among of these classes, I mean extracellular and intracellular ones, the cell-bound lipase is more advantageous than the extracellular one because it can use directly without the extraction, without the purification, and without the immobilization. So in our study, we set a two bioreactor. This is a continuously stirred tank bioreactor. One is the anaerobic bioreactor for the lipid production, And the second one is an aerobic reactor for the biogas production. For the lipid production, we divide the phase into the three phases. First phase, we use a non-sterilized polymer or without the sterilization with a different volume of the polymer we use a 3 volume, yes, and using a semi-continuous feeding strategies only. Anyway, for this phase, it's not successfully to provide a good growth and lipid production for the yeast because the normal flora or the indigenous microorganism could overcome to the yeast. Yes, and so what we do after that? We do like a second phase, use a sterilized polymer in order to maintain the yeast growth for a while, and then followed by the third phase by using a pasteurization of the polymer. So, as expected, the yeast was growing well with a high lipid productivity along with the fermentation, even though we found that the indigenous bacteria or the indigenous microorganism were still present. Actually, we found in the result from the microbial commodity composition, we found the bacteria that belong to the class of bacillus and bacilli and clostridium. Yes, actually, a species of this genera can produce endospore with have the ability to withstand heat treatments. Oh, sorry. So, for all tests, we found anyway for all tests. We found that the yeast lipid were similar. The composition of the fatty acid. So we found the oleic acid was the predominant, and followed by the palmitic acid and linoleic acid. So it's concluded that this result show that different feeding modes or different strategies with no impact on the lipid composition. This is for the lipid production. So after this, we do the biogas production. For the biogas production, we feed with the polymer after yeast cultivation. And because after yeast cultivation, the organic compound from each strategy are different concentration. So the organic loading for the biogas is different too. But anyway, we found that there were no negative impact on the biogas production. And during the production, we found the two dominant methanogenic species. Beside that experiment, we try to reduce the cost of downstream process. It means the process for the harvesting the yeast biomass. Previously, we tried to test the flocculation property of various yeast species we have. And among of all tested, Yarrovia lipolytica TSTR 5151 could show the flocculation property. And first, I would like to give you a little bit background about the yeast flocculation. The yeast that can show the flocculation property, it's composed the cell wall. The cell wall is composed of the two important components. First is the flocculation protein. It's called flocculin protein. And the second one is the polymer of the sugar named mannose. It's called mannane. And the binding of both components is affected by the pH or by the metal ion or by the cultivation of condition. So it's depend on this trend. Yes, but for our study, the phenomenon occur. I mean, the population properties occur because by not only for the binding of two components, but we can use the pH to increase the combining of both components. And we found that by using the population before sanctification, the energy and cost requirement could be reduced by the 3 to 4 times. And because we need to produce the biodiesel from the lipid that produced from the Yarrow-Valley polylatic fatty acid R5 so in this our study, we try to produce the biodiesel from the yeast by using the method named direct transesterification. So what is the direct transesterification? Why we interested? It's because the direct transesterification, this is the method, is simplified method step when compared to the conventional process because its method eliminating the drying process and simultaneously the lipid extraction and transesterification. I mean, the lipid extraction and transesterification will occur together. And this study, we designed the reactor named vigorously stir tank reactor, or we call VSTR. This reactor equipped with a special impeller that are inscribed in a type patent number 15206. You can do in that paper. And we use a 2 direct transesterification method using a chemical reaction and using the enzyme reaction. The enzyme reaction, we use the cell-bound lipase. So it means the direct esterification occur by enzyme. It means the enzyme from the yeast. So it is the its own the lipase. So both of them we describe in the patent number 15151 and 10255. Yes. And for both methods, what is the occurring? The lipid will release and the extraction and the transesterification occurs simultaneously or occurs together. So for this experiment, we found under the optimization condition of the chemical reaction gave the highest biodiesel yield around 95%. Anyway, for the enzyme reaction, yes, the lipid could be transesterified, but I think it's because there are several factors affecting the biodiesel yields in the enzyme reaction, such as the water content or molar of the methanol or enzyme activity. So we found that the production is not successfully to provide a high amount of the biodiesel. So this is the part I will further optimize, will be considered in the further work. And this is the biodiesel that we get from the methods. All of the parameters is parsed. It's look like the biodiesel from commercial biodiesel, but it's only the color is not clear like the commercial one. Okay, and I would like to many thanks to my mentor, my former advisor, Professor Dr. Benjamin Chien from the Faculty of Agro-Industry, Prince of Songkhla University, Thailand. And thank you, Professor Dr. Arini Anchulaidaki, Dr. Panagiotis Kaukias, and Dr. Laura Trun from Environmental Engineering Technological University of Denmark, for continuous supporting me and the valuable guidance. And thanks to Faculty of Science, Technology and Agriculture, Yala Rajpat University, Thailand. And thanks to the financial support from the official of the Higher Education Commission, Thailand, and incident from Technological University of Denmark. And so I would like to share you about my unique. My unique is on located in the Yala province in the southern of the Thailand near the Malaysia border. And my office is at the building 5 of the Faculty of Science, Technological and Agriculture, Yala Rajpat University, Yala. And you can follow my research from the Google Scholar or research or any application, and you can contact me via this email or the website. So I would like to thank you all for your attention. Thank you.
Okay, thank you very much, Dr. Yasmi, for sharing the experience of your research field. Those very insightful. And maybe I could say that this kind of the technology is needed in order to implement the zero waste concept in industry, right? So it was very interesting, and we will continue discuss later, Dr. Yasmi. So let's continue. For the third speaker, I invite Professor Chair Ping Lim. May I call you Professor Lim? Okay. Professor Lim is now is Associate Dean for International Engagement and a Chair Professor of Learning Technologies and Innovation at the Education University of Hong Kong, and he got a PhD degree at University of Bristol in UK. And many publications, book had been published, and also got many research funding. And actually, I got 40 pages of his CV, so that was incredible, Professor Lim. And now he will sharing with us his expert opinion about the STEM education. Professor Lim, hello.
All right.
Yeah,
Very
it's
much
good.
nice
Yeah,
you for your
good
introduction.
honors. Yeah, to us having you as a speaker in our conference today. And Professor Lim, you have 20 minutes to deliver your presentation, and please.
All right. First, like selamat pagi to all. It is a nice and hot morning in Hong Kong as well, although it's supposed to be autumn. But the thing is, I'm quite sure that there will be a lot of discussion about climate change and all in like this particular conference. In fact, last month was the hottest month in Hong Kong. The temperature was probably as high as Indonesia. Though it's like, as I said, it's supposed to be the autumn now. Right, I'm just going to share with you like my slide if I could. Okay, like you should be able to see this now. I would say that like based on the presentations that I heard so far, like the focus of my presentation would be quite different because it's based on the area that I've been working in for the last 20 years or so, looking at professional development of teachers and looking at technology-enabled teaching and learning, right? But in this case, I'm going to be looking at supporting the professional learning of teachers for STEM education, right? And I will be doing this as a chair professor of learning technologies and innovation in the Education University of Hong Kong, and also the advisory board member of the TPD at Scale Coalition for the Global South. If you take a look at my name, and if you could hear my accent, I am not from Hong Kong. I'm based in Hong Kong for the last 10 years and based in Australia for about 6 years. I'm actually a Singaporean, right? So I am your neighbor in Southeast Asia, right? So when we look at professional learning of teachers, right, we actually need to be aware of the pivotal role of teachers, right, when we are looking at STEM education in schools. I think the past keynote speakers, they have been like talking about the various issues in science and math, the type of the research. What I'll be doing here is I will be sharing with you like my research in teacher professional development at scale, right? As in, I would be looking at like how do we reach out to as many teachers as possible, right, in order to be able to ensure that there is quality in their teaching and learning, and that they are able to provide that access of quality to their students as well. Right. I think when we look at STEM education, not just in Indonesia, but across all of the ASEAN countries, right? There have been increasing emphasis on STEM education in schools, K to 12 as well as in vocational schools, vocational institutions, and also higher education. But when we look at STEM, it is a very interdisciplinary type of approach that we should be taking, right? It's a mixture of math, science, engineering, and at times it's expected to be integrated in the different curricular subject areas, may it be Bahasa Indonesia or English or history, right? So, which means that it is quite tough for the teachers because quite often, not only do they lack the content knowledge to be able to integrate STEM into their subject area, right? But the thing is, they may not have that pedagogical competencies, and they may not have even the experience, right, as they were students or as they were working as a teacher, about how to bring in STEM into their subject areas, which means that capacity building is a very important part, right? When we are trying to be able to look at effective STEM education in schools, right? So, which is exactly what I'll be looking at, right? How do we actually do professional development on such a big scale, right? Especially when you are looking at Indonesia being the largest ASEAN countries, the largest ASEAN country, right, with more than 280 million people. Right, so I'm going to be looking at TPD at scale, which is teacher professional development at scale, right? So the at, right, as what you could see is like the email at. So it's looking at ICT enabled teacher professional development. And we want this teacher professional development to be inclusive, right? And it's of high quality in order to be able to build the teacher competencies for STEM education, right? I am quite sure that the majority here, regardless of whether you're school leaders, whether you are researchers, or whether you are school teachers, right? You are familiar with the idea of teacher professional development, right? Like how do we build the competencies of teachers, right? And we often see that for teacher professional development to be effective, it got to be long-term, it got to be continuous, and it got to be planned systematically, right? So it's basically a system approach to teacher professional development, right? And it got to be strategic to develop high quality teacher at scale in a cost-effective way, right? So when we look at TPD at scale, we are actually drawing upon a lot of the ideas of effective TPD. It got to be content focused. In this case, it got to be focused on STEM, right? It got to incorporate active learning by the teachers. It got to encourage collaboration among teachers. There got to be coaching for the teachers. There got to be feedback and reflection. They have got to have opportunities to apply what they have learned, and it got to be over a sustained period of time. So what exactly is the ED? The ED would be the at scale part, right? How do we do teacher professional development at scale? So we are actually drawing upon quite a lot on the idea of learning at scale, like massive open online courses, right? If you actually look at a lot of the universities in Indonesia, right? May it be in Jakarta, outside Jakarta, on Java Island, you'll see a lot of massive open online courses, right? That we have been developing for students, especially in higher education, right? But the thing is, we could also draw upon massive open online courses in a way that we are able to reach out to teachers as well, to be building their competencies, right? I'm quite sure if you look at a university like UT, right, the Open University of Indonesia, right, they are already doing a lot of work at scale, right, trying to be able to reach out to as many learners as possible. Right, so in this case, when we look at TPD at scale, right, we want to be able to address the challenges in developing countries, in developing areas, So if we look at Indonesia, right, of course, you know, it's like the big cities of Jakarta, of Surabaya, of Semarang, right, of Yogyakarta. I mean, it is quite developed and quite accessible, right? But the thing is, once you move out of these cities, you know, to places like the Solo in central Java, or if you go up to the Sulawesi, or even go to the province of Papua, it gets a bit challenging, right? How do we reach out to teachers, let's say in the Kabupaten of the Jawijaya, right, in Papua province, right? How can we ensure that you are able to create that accessibility in a cost-effective way? So we want to be able to achieve efficiency, quality, and equity by drawing on the idea of effective TPD and also learning at scale. Right. I would want to show you some of the examples of TPD at scale, both in Northeast Asia, South Asia, and also in Southeast Asia, including one example from Indonesia. Right. This is a very basic model of how are we able to reach out to as many teachers as possible. Right. In 2015-16, the top university, or one of the top universities in China, they came up with a more massive open online courses, right, for teachers in rural area in China, right, to actually be building their capacity for quality teaching and learning. So they have different massive open online courses. So although the intention is just massive open online courses, but what is quite interesting is teachers start to share among themselves within their school, and using WeChat and different social media to share what they have learned as they are working through the massive open online course, right? And then after that, they apply in the classroom, right? So since 2017, this program by the X Learning Center in Peking University, they have actually tried to build in a professional learning community, right? To encourage teachers to be sharing among themselves, to be applying what they have learned. When we look at the India, the TEST program, it still work a lot like massive open online course. But I think is we are aware that in India, just like in Indonesia, there will be some teachers who will not have access to the internet. So how then do they learn? So they began to actually conduct large class size face-to-face using the material from the massive open online course at the district level, right? So like very much at, let's say, at the kacamatan level in Indonesia, just like in the case of India, right? And then after that, as they are working through the course, right, there is actually professional learning community whereby there is a lot of the sharing on Facebook, on Telegram, as well as on WhatsApp. The Clicks project is really quite interesting. It's also in India. As well as I said, one of the important thing is it's not just about teachers learning. Teachers learn best when they are doing. So which means that as they learn, they have got to apply what they are learning as well. So in this case, in the Clicks project by the Tata Institute, right, they are still working through a massive open online course. But the thing is, they are expected to then apply in the classroom and then share it with their peers who are working through the course as well, right? So there is a lot of reflection going on. I will now deep dive into a Philippines case, right? Because this is one of the cases, including the Indonesia one, that I'm quite involved in. The Philippines case did not use massive open online course, right? Because just like in Indonesia, they are aware that it is quite unlikely that some of the schools in the rural area or the more remote, like in the more remote area, would have access to stable internet, right? So they basically just created a multimedia courseware whereby teachers are supposed to work through it independently in their school using a computer that might be a standalone, right? And then once they have done that, they're expected to apply what they have learned in their classroom. And then they are supposed to get together once every month, right? In their school or across schools that is facilitated by a district education officer to share what they have learned, right? The district officer would be the one that will be connected to other district officers to share their experiences and what have been done at the professional learning community level. In this case, the Philippines call it the Learning Action Cell, right? What is interesting in this particular teacher professional development at scale model is that this model was developed due to a curriculum reform in the Philippines back in 2012 in the early literacy, the early language literacy and numeracy program, right, in the Philippines, right? So when we try to take a look at this, we are actually trying to attempt to reach out to more than 300,000 teachers in early language literacy and numeracy, right? If we look at Indonesia, it would definitely be much bigger than this, right? And the thing is, the lead institution is actually a foundation that I'm working very closely with in the Philippines, but also with the Department of Education in the Philippines, both the Teacher Learning Division as well as the Office of the Undersecretariat for Curriculum and Instruction, right? We actually first started with a pilot, right, that is funded by the USAID. We gathered evidences of the impact of this pilot and how it is done. What is interesting, as what I said, is teachers are learning on their own. They apply in the classroom, and eventually they are expected to share, right, with their learning action cell facilitated by an education officer from the district office, right? We are at the national scale up stage now, right? Whereby we are trying to reach out to all 300,000 teachers from 17 regions and 255 divisions all around the Philippines, right? So this is the Philippines example. In fact, during school closure in the Philippines due to COVID-19, the Department of Education have actually adopted this model of professional development, right? To try to build the capacity of the teachers for remote and online teaching and learning, right? For their students in the classroom. This is the case of the Indonesia, where we were actually working at the Kabupaten level, or what we call the Region C level, right? Because the key challenge, of course, in Indonesia is how do we reach out to like more than 3 million teachers, right, in schools to build their capacity, especially if we are looking at the capacity of teachers for STEM education, right? So we are actually talking about a whole range of the teachers, not just from the SD, SMP, SMR, SMK, but also in the also in the madrasa system, right? And the thing is, we are of course aware that in Indonesia, you already have some sort of a teacher professional learning like community in the sense of KKG as well as MGMP, right? So like how do we tap upon all this existing structure, right, in order to build the professional development of teachers, right? So we actually started working with the Putra Sampurna Foundation, the School Development Outreach Division, right? And we were actually like working more at the Kabupaten level, but of course working very closely with the province as well as the Kacamatan, right? And also getting in touch with the KKG and MGMP, right? We try to come up with a teacher learning center, right? Whereby it is being run by master teachers as well as as well as the teachers who have 50% of their time brought out by the local government, right, to serve as the administrators and the master teachers in the teacher learning center, right? Try to be looking at the professional development of between 15,000 to 20,000 teachers in that particular Kabupaten, right? At this point, when I am talking, we have about 10 teacher learning centers across 10 Kabupaten in Indonesia. We have conducted a few studies now to try to look at the impact of it. Right, so this is the model that we are looking at, right, whereby the teachers are using, actually, they are using more of Telegram to be reaching out to the teachers, especially during school closure and the COVID-19 social distancing, right? But before the social distancing, we have a lot of the professional development, which is partly conducted face-to-face. So it is a blended, right? Face-to-face supported by Telegram and Schoology, right? So the teacher professional development for the teachers is very like needs driven by the teachers within that particular Kabupaten itself, right? And then after that, ensuring that the teachers are always interacting in professional learning community, in some cases in their MGMP and also in their KKG. Right, so I have shared with you all these examples. I think the key principles that I want to highlight is that when we are looking at quality, equitable, cost-effective teacher professional development, I think we need to ensure that the digital professional learning resources that we develop for the teachers are of high quality and are accessible to teachers. We need to be looking at the curriculum, but one of the key things is really professional learning, like professional learning community, which I know that in Indonesia, you already have a rich history of that professional learning community that is often facilitated via Facebook or via Telegram. The facilitators and the mentors are quite key, right? And it will be good if it is being that role is being taken over by either the leader of the professional learning community or maybe even the district education office, right? So at the kacamatan level. Right, the support of universities, like I see many university docent here, some local governments here. I think the support is really important, right? And we need to be able to build the key partnerships. To end very quickly, we could see that TPD at scale is able to address quality, equity, and efficiency, right? We need to think through, especially for the university docent here, when we try to implement STEM education in our schools, how do we design teacher professional development in such a way that we are able to build the capacity of our teachers, right, of our gurus, right, for STEM education in Indonesia, right? So I thank you very much. This is my email address, and I will welcome questions and discussion. And if you have got any questions, do drop me an email. Thank you very much, and back to the MC. Terima kasih.
Okay, thank you very much, Professor Lim, for sharing your expertise opinion. And I'm curious, how many times you come to Indonesia? You're really familiar with many things in Indonesia. Okay, STEM education is always an interesting things to discuss. So we already listened the presentation from all the speaker we have, and now we will proceed to question and answer session. So please, for the participant, if you have a question, we still have more than 30 minutes, I think. Yeah, because in schedule we will end this first plenary session at 10:25. So for the participant, I will asking you, if you have a question, you can direct asking to the speakers that already present the presentation. Is any for the first term? Okay, I have a message in the chat box from Nila Prasetya Aryani. You will asking directly to the speakers, or I should say and deliver your question. Ibu Nila, are you join with us? Okay, from chat please. Okay, I would like to ask to Dr. Eza, based on your research, is it suitable to integrate the bioglass that you have built to bone tissue? If it's suitable, how about its safety? And it is suitable to put bioglass from waste material? Maybe you can directly answer, Dr. Eza.
Okay, thank you, Ms. Nila, for the question. Okay, I will answer the question. Okay, yes, it is suitable to integrate the bioglass to build the bone tissues. As I said just now, there are a few parameters that we need to consider, especially on the composition, okay, and we can see from the SRD and also the porosity as well. So what we need something, okay, some material that suit the structure of our bone and teeth. Okay, so we can do the FTIR, the SRD, and actually how we want to prove it later on, we will use the SBF. Okay, it's like we immerse in the, it's like body fluid, right? So we will see the result, and yes, it is suitable.
Okay, thank you.
And for the from waste material, yes, it's possible as long as the composition is matched. The composition, the structure, there are many factors for the biocompatibility, the nature, the chemistry, the mechanical, the bioactivity. So all of this, if we can prove it is a match, so yeah, inshallah we can use it. Thank you.
Okay, thank you. May I asking also Dr. Eza of a forward question, and I'm curious too, and about the implementation of the bioglass in the market. How many percent this technology really implemented or used in a medical use? And I guess it will be very expensive if really to implement. And how many percent this technology really implemented in the medical use, Dr. Eza?
Okay, basically the cost of biogas is much more cheaper, much more lower than the implantation of using the metallic and etc. It's much more lower. And as I said just now, because the composition is matched, okay, for all sample, so we can produce in the large scale. So if Prof. Larry Hench, as he invented the bioglass, yes, they use widely in the medical as well. They already use widely for the tooth, for the bone fracture, and yeah. But recently, in 2004, they started to change, okay, to embed the surfactant in the conventional soldier. So now we focus on the odate porosity instead of just the bioglass, but we need the odate porosity mesostructure. So it can encourage the rate of hydroxyapatite forming the bioactivity, bioavailability.
Okay, thank you very much. Cheaper than the conventional technology. Okay, very good. And then we also have a question to Dr. Yasmi. Maybe you will asking directly, or I should read your question.
Yes.
Maybe please.
So for the first question,
yeah,
how to release lipid?
The question is how to release the lipid and lipase at the same time from the yeast cell in the biodiesel process.
Please imagination, when we imagination the oval cell of the yeast, the cell wall is on the surface of the between the cell wall and membranes, between the cell wall and membrane, and the lipid will accumulate inside of the cell. So this is a two products, and in the bioreactor we decide we use a special impeller and use a high agitation rate. So when the cell is attacked with the high rate of the impeller, it will break, and the lipid will be released, and some of the lipase between the cell wall and the membrane will be released too in the medium. We call the medium. This is a methanol. Yes, this is a methanol. So I'm not sure this is I answer clearly this question or not.
Okay, thank you, Dr. Yasmi. Still many questions in the chat box. You can also see, right, on your Zoom platform. And the next question, maybe I will asking directly to Dr. Yasmi. Esterification usually requires an acid or base catalyst to speed up the reaction rate. Do lipase have a characteristic that can accelerate the esterification reaction? That's the question, Dr. Yasmi.
Yeah, for first, in my presentation, I already read a little bit background about the lipase. The lipase is one catalyst that can do like acid or the base in the transesterification too. So, but for the speed up of the reaction, it's depend on some condition that can affect on the lipase, because the lipase is the micro. This is the it's not the chemical. So many things will be affected when it's transesterified by the lipid from that. So we found that the rate of the use with acid or base and compared to the lipase is a difference because of that. But the lipase can do the transesterify, can do the esterified lactic acid and lipase too. Yes.
Okay, still, there's a question. Is it possible if we change the yeast with almost the same activity, another yeast, change with another
Change with
yeast?
another yeast.
Yeah.
Yes, we can, but we should screen or isolate the yeast, that species that can co-oleaginous because just some species that can co-oleaginous, that because they can accumulate. Yes, I told you I talked to you with in my background in my presentation that we can call the oleaginous because that can accumulate more than 20% lipid in their biomass. So not almost of the yeast can do that, and not almost of the yeast can produce the lipase too. So we can change to another yeast, but you should to screen or isolate that yeast you can use for that method. Yes.
Okay, thank you. Move to another education question to Professor Lim. Many question too, and maybe I will asking again for the participant if you would like to say directly to the speakers. It's okay. We have from UNYF MIPA in Si Wilujeng. If you would like to asking directly, please. The question to the Professor Lim. If no,
okay, thank you.
Yeah. Okay. Yeah.
Okay. I have 3 questions for Mr. Lim. The first question: what are the meaning of technology and engineering in the STEM framework? Are they always related between technology and engineering? And the second question, often become the teacher debate. Technology is application the concept of science, or technology as the medium for understanding the concept in science. Please, your description for Mr. Lim. And the third question, in the professional development of natural science teacher, STEMs begin to integrate it with art to become the STEAM. Can art be linked the engineering and technology? Thank you.
All right. Terima kasih Ibu for the questions. Very, very, very interesting. I mean, when we look at STEM and when we look at technology, in terms of STEM education, technology should be seen from 2 perspectives. I think one perspective would be to actually understand the technology itself, right? So it might be about coding, right, which is a lot about programming. It got to be understanding AI and let's say understanding AI, understanding big data, right? So this is one perspective of technology in STEM education. But the other perspective in STEM education is that we are actually using technology to enable the understanding of STEM, right? So we are using technology to understand science. So let's say using a simulation application, right, to understand how E is equals to mc squared, just for example, right? So when we look at the meanings of technology, I think we are looking at it from 2 perspectives, right? One from the perspective of technology enabled STEM, right? So using technology to understand STEM, right? And the other one is actually looking at the technology itself, right? From being able to do coding and being able to develop robotics, etc., right through to the ability to actually understand the concept of artificial intelligence, big data, etc. Right. So that would be one. The second question is with regards to the application, like technology is the application. Is the application of concept of science or technology as a medium for understanding. So this would be related to my response in the first question, right? That it really depends on what perspective you take. And quite often we are looking at both perspectives, right? The understanding of the technology and using the technology to understand STEM. The third one, I really like the idea of STEAM, right? Because I am actually more trained in social sciences in terms of the economics, right? So in fact, the S1 was in the economics, right? So STEAM or the arts is always quite a big part of my thinking, right? So when we look at art, yes, it should be able to link to engineering and technology. If you look at a lot of the art that are being done, right? Say if we look at art as in art itself, I mean the visual art, right? When I go to the schools of both my daughters, right? You could see how they use a mixture of technology and the engineering, right? To actually be doing visual art in their classroom, right? Using 3D printers to be creating different art pieces, right, in their art classes. So again, we are actually looking at how we could be drawing upon the components of STEM in order to actually enhance the learning of art, right? And as a result, right, you'll be able to pick up some digital competencies at the same time. All right, I hope I actually answer your question. Thank you so much indeed.
Okay, thank you, Professor Lim. Still continue asking the question, maybe from Bapak Prasetyo Listiaji, you will asking directly to Professor Lim. Bapak. Okay, please. Bapak? Yeah?
Okay.
Okay.
Thank you. Thank you, Mrs. Rifa, for the opportunity to ask a question. I want to ask to Professor Lim. Okay. My question is, in Indonesia, the number of the teacher is very large, yeah. But not only the number of teacher, and the number of the teacher candidate or pre-service teachers is more higher than the numbers of the teacher. Because many university produce the graduates, teacher candidates. My question is, in your opinions, how to prepare on equip the teacher candidates to become professional teacher, especially in the skill of STEM education, and how can the TPD Scale Indonesia can offer this program to develop and equip the teacher candidates to be professional teacher? Thank you.
Yeah. Thank you so much, Papa. It's quite an interesting question, because whenever we present such a model, it's like there is that assumption that we are just looking at in-service teacher education, but I think you have rightly pointed out pre-service teachers as well, right? Those in UNJ, UNY, UNS and all, and also those in the FKIP, right? Think when we look at pre-service teacher education, I am aware that if you are looking at the big state universities like UNJ, UNS, and UNY, it's like these are big state universities with quality docent and maha docent, right? So you have quality teacher educators there. But quite often, if you go to a FKIP, right, in let's say a province in East Kalimantan or in Papua, right, the quality of the teacher educators could be quite a challenge at times, right? So at times, I am actually thinking that how do we build the capacity of these teacher educators in those FKIP? And at times it is quite difficult too. So how then could the state universities, for example, UNJ, UNY, UNS, it's like how do you work together, right, with the FKIP in this small little FKIP, right, in the more rural Kabupaten, right? How do you improve upon their pre-service teacher curriculum, right, to ensure that eventually the pre-service teachers who graduated from this FKIP, right, would be able to actually deliver quality teaching and learning in the schools within that Kabupaten or within that province itself. Because one of the big problems, I'm not too sure if you are actually aware, right, is that when we start to bring graduate teachers, right, the graduate teachers from the city, right, who have graduated from UNJ, for example, or UNY, for example, right, and actually put them in a rural and remote schools. It's quite a challenge for these young graduate teachers. And quite often they do not stay long within the school because they are not used to the lifestyle, they are not used to not having electricity during the night or not having running water, right? It could be quite a challenge. But if you are able to actually build a capacity of the FKIP, right, at either the Kabupaten level or province level, and be able to use these graduate teachers who are actually from that particular Kabupaten or that particular kacamatan to eventually serve in the schools in their community, then that will be quite exciting and ensuring the quality gap between, let's say, the schools, let's say a SD in the Jayawijaya, right, having the same quality of teaching and learning as a school in the Jakarta, right, that the teaching and learning is of the same quality as well, right? So I think we really, as what you have rightly pointed out, to really think of ways of how do we improve pre-service teacher program quality. And I would say that when we look at a program in state universities, right, they are of very high standards. But once you move out of the state universities, it's always quite a challenge. Thank you.
Okay, thank you very much, Professor Lim. I'm so curious, how many times you come to Indonesia, Professor Lim? Because you are so familiar about many things in Indonesia. So, yeah.
I actually spent 2 months in Papua, 1 month in Jawijaya. So
Oh my, yeah, you
yeah,
already
yeah.
go to the
But
Papua also.
like that was like 10 years ago.
Okay, we still continue because you have many questions here. We also see from the chat box there are participants from Cambodia. So would you like to asking directly to the Professor Lim? Hello, are you joined with us? I'm so difficult to spelling the name. I'm afraid if I wrong to spell the name. Hello? No? Okay, maybe I can deliver the question. For Professor Lim, I'm wondering what are the key components of the teacher's competency that was designed for an intervention to improve the STEM teacher competency in Hong Kong?
Yeah, this is quite an important question because I think our Cambodian colleague have rightly pointed out that in order to carry out professional development, we need to know what are the competencies that we are trying to build of our teachers for STEM education, right? So it is a conversation that quite often a lot of education leaders do not engage in. So when we are looking at STEM, right, in terms of the content, what in terms of science, technology, engineering, and mathematics do we require, let's say, from the Bahasa Indonesia teacher, right, or from the English teacher, or from the art teacher? Those are not clearly articulated. So what is the minimum requirement that they need to really understand about science, technology, engineering, and mathematics? I would say that though like across the ASEAN countries and including countries in the Asia, a region like Hong Kong, we talk a lot about teacher competencies, right? But we never talk about the competencies that teachers need to implement STEM education, right? And the thing is, to implement STEM education, it will actually depends on the subject area that you are in. We do not expect that say a Chinese teacher, right, in Hong Kong, having the same STEM competencies, right, as a, let's say, a science teacher, right, in Hong Kong. So we need to ensure that it is quite context specific, right, that the expectation is quite clear. But I think up to this point, we have not been able to articulate those key competencies. So I would really want to thank the Cambodian colleague for highlighting that, right? That in the first place, we need to be upfront about what are the teacher competencies required to implement STEM education in each subject area. And each subject is very different. Thank you.
Okay, thank you, Professor Lim. And if can asking for the forward, based on your experience developing STEM in many countries, what is the major different characteristic between the developed country and also in the developing country in implementing STEM concept, Professor Lim?
Is actually more of the conducive environment. I think one is always with respect to infrastructure and devices, right? It is actually quite a challenge when you do not have the infrastructure and devices. Quite often, developed countries have those infrastructure and devices, but does not mean that if you have the infrastructure and devices, you are able to carry out STEM effectively, right? Because if the teachers do not have that capacity, you're not able to do it, right? I have seen fantastic example when I was working with like a docent, right, in the UP, right, in Bandung, right, where they were looking at some of the rural schools in West Java, right, where they actually try to use recycled materials, right, and very low cost material to carry out STEM education in terms of trying to look at climate change, right, within a science classroom. Again, yes, infrastructure and resources are very important, right? And that is the difference between developed and developing countries. But I think sometimes it also depends on the capacity and the innovativeness of the teachers. Those teachers and those docents that I was working with, right, in West Java, right, it's quite obvious that they are able to carry out STEM education as well, because they are able to make use of the very limited resources that they have, because they have the capacity and they are innovative, right? But I think that is only able to work sometimes when there is a closer partnership between the university and the schools, right? Quite often you're not able to see that close working relationship between schools and universities. Though I would say that in the last 10 years, I am beginning to see more and more of that in Indonesia, right, as compared to 10 years back. Thank you.
Thank you, Professor Lim. We still have time. One question again for Dr. Yasmi. You can read on the chat box also. Actually, what is from Ibu Ratna Dewi Kusumaningtyas? I'm asking to deliver reading by the message. Actually, what is the advantage of enzymatic transesterification for biodiesel production? And I conducted for both the chemical and enzymatic biodiesel production, and she's found that enzymatic biodiesel production is very slow. The enzyme or immobilized enzyme is expensive, and the yield is low and a longer reaction time than the chemical reaction. It took interesting for kinetics and modeling, but no economics. Can you answer, Dr. Yasmi, for this question? Oh, okay. Already not join us. Okay. Maybe we will contact and then for this kind of the question. So still have time or? Okay. Two question again. Okay. From would you like to directly asking, or I should read your message already? Okay. Question again, Professor Lim. Based on your experience, how can a teacher implement STEM-based learning in those frontier, outermost and least developed region in Indonesia?
Yeah, I think this is a fantastic question from the Indra, from the UM, because we talk a lot about the equity, like the issue, and it's like when we try to be able to work with schools from the very remote area itself. Okay, we cannot expect that basically every school in Indonesia would be using the same type of devices or same type of equipment, because that's just realistically not possible, right? I think quite often when we look at STEM-based learning, I think STEM-based learning need to be based on the environment in which the school is being situated in, right? In fact, I actually visited one school in Jayawijaya, which is about 2 days walk from Wamena, right? and it was a really exciting and vibrant school that we just walk in without any like warning at all. But the thing is, the kids were all involved in working in a science classroom using materials that could be found in that particular kampong, right? So I thought like that was really a good example, right? Of actually, it's not about the equipment. Yes, of course, we want to be able to have access to equipment, right? That would be the most ideal situation. But I think what is really important about STEM-based learning, right, would be really about how do we make use of the resources that we have available, the problems that we have in our environment around us, right? May you be in the city or may you be in the most remote area, right? But I think for STEM policymakers and leaders, what they need to keep in mind is what is the minimum that is required, right, for STEM education to work in terms of the equipment, right? So which means that how could we equip all schools, regardless of whether they are in the remote area or whether they are in the cities? So what are the basic equipment they will need? For example, data logger, right? Like might be one of the so-called most basic equipment that they would need, right? But I think the emphasis should be how could teachers be more innovative to make use of existing resources that they have within their school. It does not mean that if I do not have the equipment, I do not engage in STEM education or STEM learning itself, right? Basically, what I'm saying is it is possible too. So thank you so much.
Yeah. Please allow me for last question maybe. Yeah, this is from Bapak Ibu Ayi, Bapak atau Ayi from Unimed. Maybe this is the last question. I have one question. Is it possible in the future research to propose how the spiritual aspect can be achieved with STEM learning design? Yes, Professor Ling.
Yeah, yeah, I think it would be, it is an important question because you know, it's like there have always been talk about technologies taking over humans. I think when we are looking at the spiritual aspect, we are actually looking at beyond just cognitive and the physical aspect of STEM education itself, beyond the pragmatic the aspect. So you have rightly pointed out that when you are looking at STEM, right, you should be looking at the spiritual aspect or the emotional aspect, right? Because you really need to ensure that as students are working through STEM, that we are actually also developing them as a human being, right? So which means that there need to be discussion about the moral implication of artificial intelligence. So it's not just about getting involved in technologies, but to get engaged in debates, right, about the pros and cons about technologies, right? The ethical use of big data, privacy issues of big data, of learning analytics, of analyzing big data set, right? So I totally I totally agree with the person who have highlighted the question of the spiritual aspect. I think you're really talking about like being human. As we are doing STEM, we got to be able to deal with the human aspects of STEM education as well, which is about the so-called the ethical use of technologies, right? We need to get into those conversations, not just using the technologies, right? Not just like knowing science, but be able to make ethical decisions about science. Thank you so much.
Okay, time is up. Okay, thank you. Thank you very much for all the speakers for the answer, and we apologize could not deliver all the questions to the speaker due to the time limit we have. And shortly we will end our discussion today, and research topic regarding the science and also education will always continue evolve according to the times. And many thanks to the speaker for sharing in this session. Please give big applause, emotion maybe, to our speakers today. And thank you for the attention from all the participants. And personally, I would like to apologize for inappropriate response during this session. Hopefully, our discussion will give a beneficial for us. And good morning, and wassalamualaikum warahmatullahi wabarakatuh. Time will be back to Miss Stephanie.
And Zainal Abidin, PhD from Indonesia. And this session will be guided by Arif Widiatmoko, PhD. I'd like to present the profile of Arif Widiatmoko, PhD. He is lecturer of Integrated Science Department, Faculty of Mathematics and Natural Sciences, UNES. He finished his study in Universitas Negeri Semarang for bachelor and master degree and continued his doctoral degree in Hiroshima University. His research interest is in science education field. For moderator, time is all yours.
and assimilating their own existing theory and social culture, actual phenomena, and socially accepted theory. So students already have some knowledge. It may not be scientifically correct, but they have some idea. So give them chances to apply such idea, confronting with actual culture or theory and phenomena. And then please click. And then by giving a responses, students will assimilate, their actual knowledge. Yeah. By using such training, students will learn how to doubt and how to get robust theory. Yeah, go ahead. Yeah. So by applying this construct, by applying this constructivism, what we can say is that teachers should give opportunity for students to express various ideas. And sometimes it is important to pause the video and allow students to think about the questions and letting them to check their idea, by video. Yeah. I wanted to use some video clip sample, but since I cannot control the screen sharing, I would like to stop here, and I would like to set several questions.
Okay, thank you very much, Professor Kinya Shimizu. And is it directly question and answer, or we move to next speaker? Shimizu Sensei. So
yes.
This is you would like to have a question directly, or I can go ahead to continue this next speaker.
Well, if you don't have any questions, you can go ahead. But probably I will leave here, but I will come back. So if you have any questions, please put it on chat.
Okay. Thank you very much.
Right. Thank you.
Okay. Thank you very much, Professor Shimizu, for that very insightful presentation. Okay, if you have any question for Shimizu Sensei presentation, please write your question in the chat box. Okay. Okay, and now moving forward, we will listen to the next keynote speaker, Safik Asmi, PhD. Good morning.
Good morning, Dr. Arif.
Okay, thank you very much. Before we begin, allow me to briefly introduce our speaker by reading his curriculum vitae. His full name is Muhammad Safik bin Asmi, PhD. He's a senior lecturer at School of Biology, Faculty of Applied Sciences, University Teknologi Mara, Malaysia. He graduated Doctor of Philosophy in Metagenomics UITM, Master of Health Sciences UITM, and Bachelor of Medical Laboratory Technology, Faculty of Health Sciences UITM. He has many publications that had been published in many reputable journals. And now he will present the topic, Metagenomics Approach to Unravel the Association of Gut Microbiome with Health and Disease. Dr. Safik, thank you for joining us in this conference. We are pleased to have you here. And then you have 25 minutes to deliver your presentation. Okay, time is yours.
Right, thank you, Dr. Arif, for your kind introduction. Wait, I share with you my slide. I think I cannot share my slide here because I don't know
Okay, wait a minute. Okay, try again, doctor.
Right. Okay, it's perfect now. Right. I hope that you could see my slide.
Yes.
All right. Okay. All right. Assalamualaikum, and I think almost good afternoon, right? So I'd like to say, first of all, thank you so much for the kind introduction from Dr. Arif. My name is Shafiq Azmi, and I'm from Faculty of Applied Sciences, UiTM, Malaysia. So today, I'm going to share with you some information regarding of a topic metagenomics, which is very dear to me, metagenomic approach to unravel the association of the gut microbiome with health and disease. Was not. All right. This is the outline of my session right now. First, I'm going to introduce you the concepts of the metagenomics, and then I'm going to share with you common approaches and also workflow that have been used in metagenomic studies. And then I'm going to share with you as well the analysis pipeline and also some of the basic interpretation on the obtained data from the metagenomic studies. And lastly, I would like to share with you some example of the application of the studies in the gut microbiome that we conducted in Universitas Negeri Semarang. First, allow me to share with you the definition of the metagenomic. I'm sure that some of you had familiar with the terms of metagenomic. For those who are still not, metagenomic can be defined as the study of the collective genome of microorganisms recovered directly from their natural environment. So it could be from soil, water, or even your skins, or even your nails and everything. All right. So this technique is actually advanced techniques related with the next generation sequencing, allow you as a scientist to bypass the need for isolation and also lab cultivation of individual species. And the power of these studies is actually able to provide an information on the microbiome diversity and also ecology of the specific environment. So now, when you do the studies on metagenomic, basically the scientists wish to understand the dynamic nature of the microbiome population and their impact on the environment or even in human health, depending on your subject of interest. So since microbes play an enormous role in the process that relate to nearly every aspect of our planet, maintain the atmosphere and ecosystem, help us to harvest energy and nutrients from our diet. And just now from Dr. Yasmi's presentation about the wastewater treatment to create the biofuel, involvement of the fermentation of the microbes, fungus, and all that. So you can apply this technique to understand further about the endosymbiont of the bacteria that have been helping in that fermentation process to convert the wastewater to biofuel. So usually, I summarize, there are three main scientific equations, and usually your hypothesis always revolve on this. First scientific question that you wish to ask to yourself and also your study design is actually, who is that? Basically, what are the composition or profile of the microbiota or microorganism in that particular ecosystem? Next will be, what are they doing? Basically, what they're doing in terms of what is the functional gene that have been encoded within that particular microbiome of that particular ecosystem. And then, of course, when you observe and you manage to see the profile of the gene that have been encoded, of course, you want to know how are they doing. This is more into the functional studies, right? Okay, when we talk about the metagenomic studies, there are two main techniques that have been used widely. First is 16S sequencing. Second is a shotgun metagenomic. 16S sequencing is basically focuses on the amplification of the prokaryotic 16S ribosomal RNA gene, and we sequence it, and then the presence of this gene in all bacteria, and it's kind of a universal phylogenetic marker for us to differentiate between one species to another. So that's why this technique has been employed by scientists in metagenomic study. The second technique that could actually produce more robust, bigger data is a shotgun metagenomic. The term shotgun itself means that you just extract the microbiome DNA from any samples, stools, or soil or water. Then you extract it and you fragment the DNA using sonication and share it into the fragment, and you sequence right away without any involvement of the amplifications of the CCNS gene. So it contains collections of all the genes that have been encoded in every species in that particular ecosystem. All right, so now I'm going to share with you some differences, in terms of the advantages and disadvantages of each techniques. For the CCNS, as I mentioned before, the principle focuses on the multiple target regions of the CCNS genes, whereas shotgun is more into like whole genome. Okay, whole genome. So the advantages of the CCNS is actually provide you a faster way of a large communities. So if your scientists have some hypothesis that you want to prove a concept, usually people go for the CCNS, and it's good for the first round survey of the microorganism in any particular ecosystem. And it's quite cost effective, which is cheaper than shotgun. Whereas for the shotgun, no application bias, because you just sequence the DNA directly, from the ecosystem and the sample. And the advantage of this shotgun technique is actually provide a community-wide assessment, of both bacterial compositions and also complement functional gene presence, And of course, some advantages for the CCNS is actually there is an amplification bias because you have to amplify the CCNS gene prior to the sequencing, and of course, it will introduce sequencing error. Whereas for the shotgun, it's a very computationally expensive resources because the data is huge and you need to have processing service and so on. All right, so I hope that you're not overwhelmed with this figure. This figure is actually summarize how people mine the microbiome depending on the technique that I've mentioned earlier, either CCNS or shotgun metagenomic. For the CCNS, basically you have to amplify the sequence CCNS, and then you have to perform bioinformatic analysis. You group the similar sequence into similar OTUs or operational taxonomy units, meaning that if the species had shared the same CCNS gene sequences, they will be clustered as the OTU1, OTU2, OTU3, or OTU4. And then after that, you have to perform the blasting and also annotation against several sets of databases that containing CCNS genes. For example, green genes, MyRDP, and also silver. And then after that, usually, the occurrences of these OTUs could be inferred as the relative abundances of that particular species, in that particular system or ecosystem or community under study. Whereas for the shotgun metagenomic, required assembly depending on your hypothesis, whether you want to identify any novel species or gene function, or you just want to profile a common composition. And then after that, you have to perform additional annotation on the functional gene in KGG, seed, BLAST databases. And then the advantage of the shotgun, as I mentioned, they provide you two main information. One is the profile of the microorganism, similar to the CCNS, and then additional, the relative abundance of the gene that have been encoded to that particular microbiome. Okay. All right. So now, for the first question of that usually we will going to ask in the metagenomic study is, who is that? So how people actually answer this question is basically based on the profile that you got from CCNS or the shotgun. Okay, you're going to report the abundance of the bacteria according to the taxonomy hierarchy, usually from phylum to the species. All right, the bacterial distribution will be presented usually in a pie chart, bar chart, or histogram. For an example, here in the first pie chart, you could see that 96.9% of the data is actually comprised from bacteria. So you can say that that particular ecosystem is contained 96.9% bacteria. And then the second pie chart here with the multiple colors, sections, and all that represent, a relative abundance of the C7S genes, according to this each genus of the bacteria. For example, acidobacteria, actinobacteria, bacilli, and here you can see that 24.1% is actually belongs to alpha proteobacteria, right? And then, of course, when that is considered descriptive, but then bear in mind that gut microbiota is very dynamic and very adaptable to the changes in the environment. Therefore, we can say that they have inherent plasticity characteristics. Therefore, you need to perform a comparative metagenomic in order for you to identify the biological importance of the bacterial species that have been sequenced before. Or else you're going to get like thousands of bacterial lists of the bacterial species in your data, and you don't know how you want to proceed or to make any conclusion or inferences of it. So usually people will compare diversity of the species of the bacteria based on the 3 different scales. First is the alpha diversity, second is a beta diversity, and third will be gamma diversity. Usually people from the ecology background will understand this. But allow me to share with you some definition of these. Okay, alpha diversity is basically you describe the species diversity within a community at a small scale or within the same community, whereas beta diversity is between 2 communities and gamma is several ecosystems. For example, here in the figure 1, you could see that there are. I hope that the figure is clear enough for you to see. There are 4 clusters of data profile presented in the principal component analysis. The green one circle is actually the profile of the obese gut microbiota, whereas the rest is actually profile of a gut microbiome under the probiotic treatment and also the link. Here you can see that when we talk about alpha diversity, you just talk about the richness within the each circles, and then if you will talk about the beta diversity, you compare between the obese control, the green one, compared to the blue one, obese treated with the probiotics, or the lean control profile in the red circle. And then gamma diversity is basically you compare all these between the intervention groups. All right. And because of metagenomic data usually is very high dimensionality, it's kind of a big data actually. So you need to perform univariate analysis and multivariate analysis. You need to reduce the dimensionality to identify the key components or very important out of this data. Usually in univariate analysis, people will use 4-change, t-test, Manrini, and ANOVA, which I'm sure that you guys familiar with the principle and theory. And the multivariate analysis is actually to describe, to identify or visualize pattern of the metagenomic profile. As I mentioned here in the figure 1, you want to show, to visualize that the profile of within obese rats and also the lean host is actually 2 different profiles, and to reduce the dimensionality. So usually people use a principal component analysis or partially square discriminant analysis. All right, now next question will be, what are they doing after you know the profile and you perform some sort of analysis and you see that yes, there is differences in terms of the abundances, profile. Some bacteria is reduced, some bacteria is actually increased, statistically significant. So what are they doing? So if you do the shotgun metagenomic, you're able to actually annotate the functional gene with the aims to first elucidate the functional capacity, of the microbiome in a specific condition. Second is actually sort of to catalog, the collection of the gene in the microbiome, particularly if the ecosystem is very unique, and thirdly is to estimate the abundance of the specific metabolism pathway and any shift after given a specific intervention modulation. All right. So here, for example, in this figure, it shows some example of the gene annotation. Okay, out from the shotgun metagenomic, you could see that a list of so-called seed pathway or metabolic pathway that usually been annotated in a bacterial genome. For example, carbohydrate gene related to the protein metabolism, gene related to the cell wall and capsule. And you could see that the bar in the blue color represent the occurrences or the abundance in terms of relative percentage of the reads that been annotated to this particular gene under this metabolic classification, right? All right, so now, of course, after you know what they're doing, what they can do and how are they doing, okay, that one is more into descriptive and a gene-centric analysis. But in order to answer this, you need to carry out or proceed a functional studies. All right, this is a quite interesting studies because you need to employ multi-omic studies. Why? Because you need to perform you want to answer the question is how does the community respond to its environment? So it's like a central dogma, right? From if you have a gene content, of course, you need to be translated and transcribed into protein and all that, involved on the enzyme and everything to react and to produce some kind of a mechanism in the body. So you need to perform meta-transcriptomics, meta-proteomics, and also metabolomics, to distinguish, the active from the inactive members of the microbiome. For the first two studies is like kind of a descriptive, and this the third question, how are they doing, is actually more into causation and functional analysis. All right, now I'm gonna move to the applications. Gut microbiome in obesity. This study has been carried out in a faculty University of Technology Semarang, collaboration between Faculty of Applied Sciences and also Faculty of Pharmacies. Why obesity? I think all of us know the reason is the global health burden. In fact, for Malaysia, right? Malaysia is been reported to be the fattest country in the Southeast Asia. So when we talk about the obesity, right, it's a multifactorial disease, right? When you talk about multifactorial disease, it could be due to the genetic predispositions or the environmental factors. When we talk about genetic predisposition, some people inherited certain short nucleotide or genetic variant and involved in the genetic regulation in the satiety, carbohydrate, blood sugars, and everything. Whereas the classical factors, for example, for the environment, factors such as poor eating habit, sedentary lifestyle, increase our predisposition and risk to get obese. And compelling evidences, I think since 10 years ago, lots of evidence showing that the interaction between the gut microbiota and also poor dieting habit that leads to the obesity. And why gut microbiota is the interesting subject to be studied on this kind of health and diseases, because as I mentioned, gut microbiota is the collective of microorganisms. So it's actually comprised from bacteria, viruses, parasites, also fungi, and the density in our gastrointestinal tract is up to 10 power of 11 microorganisms, and within 1,000 bacterial species, and with the millions of the functional genes that have been encoded by this particular microbiome. So obviously they involve in nutrient and energy harvesting, and with the adaptability with the environment changes due to the diet, they have an inherent plasticity characteristic which often provide an avenue for scientists, to use or to apply biotherapeutic using functional food, for example, probiotic, prebiotic, even herbs and all that, to modulate any dysbiosis of the gut microbiota due to the poor dieting habit. And then, in a way that the aim is actually to ameliorate the obesity and also comorbidities, right? All right, to prove the concept, we developed an animal model here. There are three groups, G1, G2, and G4. G1 is actually the control obese rat that have been fed with the high-fat diet 60% for 21 weeks. The G2 is the obese rat that have been treated with the probiotic, Lactobacillus casei, Shirota, for 12 weeks at a dosage of 10 power of 9 CFU meal a rat per day. And then G4 is the control lean rat. So after 12-week oral supplementation with the probiotic Lactobacillus casei, we could observe that defined body weight, energy intake, subcutaneous fat weight, total fat weight, total cholesterol, leptin, also triglyceride were significantly lower as compared to the obese control groups. Okay. And of course, these spark an ideas that, okay, all right, probiotic supplementation able to reduce or improve the obese phenotype, as I mentioned here. So how about the gut microbiota profile? Because that's guide us to the second scientific theories. So we perform shotgun metagenomic sequencing, and true enough, we could all see that obese gut microbiota are totally different from obese gut microbiota profile that have been treated with the probiotic, and also the lean gut microbiota. You can see here clearly based on the PCA score plots. Okay. And then using univariate statistical analysis, we identified 25 bacterial genera that have been affected specifically under the high-fat diet. All right. So in red is actually 17 genera that have been significantly increased and found positively correlated with the obese phenotype, high body weight, total cholesterol, and all that. And then we observed that reductions of 2 genera, Rumnicoccus and Sobrigella, were negatively correlated with the obese phenotypes, meaning that as the body weight increased, these abundance of these 2 bacterial genera will be reduced significantly. That is the trend. And under the probiotic supplementation of L-beta-13, which is Lactobacillus casei, there are 35 bacterial genera that have been affected specifically under this treatment. All right. And among these 35 genera, we observed that certain genera that, as highlighted red here, is actually positively correlated with the improved obese phenotype, whereas 10 bacterial genera, as highlighted in a purple, were found negatively correlated with the obese improved obese phenotype. And among the increased 16 genera, we observed that several enrichment of bacterial genus, like for example Bacillus, Eubacterium, Rumnicoccus, that have been reported to have cholesterol lowering effects, okay, which provide natural hypocalcemic effects under this probiotics treatment, which in tally with our phenotypic observation just now that I presented to you. So we can say that changes in the composition of the gut microbiota might suggest changes in their metabolic capacity in obese and post-probiotic treatment. So now we want to know what they're doing. So how about the occurrences of the functional gene that be encoded with this profile of the gut microbiome? And true enough, when we perform the annotation of the functional genes, and we've observed that probiotic monocytic gut and lean gut microbiome had lower occurrences of a gene related to the fatty acid metabolism, for example, fatty acid metabolism cluster, biosynthesis, degradation, cholesterol metabolism, as well as in the metabolism related with the nutrient transport, sugar phosphatase, ABC transport. So we can say that obese gut microbiome has more capacity to harvest the nutrient and energy into the body of the host. All right. So the second application that I wish to share with you is this collaboration with Faculty of Medicine, Universitas Negeri Semarang. So this is a fresh from the oven. So we would like to study about the compositions of the gut microbiota in a Malay pregnant woman, and we want to see whether the profile of the gut microbiota, CCNS, is differ between trimester of the pregnancy, body mass index, and also with those having gestational diabetes status, because lots of compelling evidence showing that gut microbiota profile and also maternal health has a significant impacts on the well-being of their babies later on postpartum. So we recruited 38 Malay women, and then we collected their fecal samples and performed CCNS gene. So we want to compare between trimester 1, T1, and trimester 3, and then normal versus abnormal BMI, body mass index, and then healthy versus those who having gestational diabetes mellitus. All right. First hypothesis is that whether the gut microbiota profiles are different by trimester. Based on our finding, the profile is not differ much based on the figure 2B, and maybe perhaps we can increase the accuracy of our analysis by adding more or by recruiting more samples in the future. All right. However, we managed to see that the profile of the gut microbiota are actually differ between pregnant women that have gestational diabetes with the normal one, right? As presented in the figure 4.b. And from the variable importance analysis, we observed that several bacteria that have been associated with the inflammations and everything in the other studies have been found contributed in the differences of this gut microbiome profile between GDM patient woman and also the normal one. All right. Okay. Next will be we observe and we noted that the profile of the gut microbiota between normal BMI and also obviously BMI is a difference. And then in the mild underweight, for example, we could observe that several bacteria that have been associated with a good health microbiome profile in other studies being found elevated. For example, one of it is Akkermansia. Akkermansia mancipula has been proposed as a new probiotic and been found to be a good functional food for obesities and comorbidities and all that. So although these are not definite studies that can conclude everything, but it gives you some kind of knowledge and concept, for you to move forward. All right. So in summary, the metagenomic approach could determine the dynamic natures of the microbiome population and their impact on our health. So today, I can say that most studies are more on descriptive and also correlation studies rather than causation studies, which require functional studies and employ lots more multi-omics approaches. However, we could get an idea of which bacteria that may play a role in the observed phenotype. Like the case of the obesity and GDM, knowledge on the compositions of the gut microbiota provide an avenue for the application of biotherapeutics, such as probiotic or natural products. So we can isolate that particular bacteria and test on the germ-free mice, to see whether the similar phenotype could be observed later on as our previous animal model before we propose as for the human studies and all that. So for example, high fiber diet could be served as a nutrient to the gut microbiota, which could modulate the condition of the gut microbiota. I believe that in Malaysia, we have our fiber diet is low in consumption. So that's why metagenomic is a good study to explore. And with this, I would like to end my session. But I would like to say thank you to the organizer once again, Universitas Semarang, and also UiTM as well to fund these studies and to provide all the facilities and resources for my research. Thank you.
Okay, thank you very much, Dr. Safik, for sharing the experience on your research field. Your presentation is very insightful. Once again, thank you very much. Okay, if you have any question, please write down your question in the chat box. And don't forget to mention your name and your institution. Okay, let's continue for the third speakers. I invite Zainal Abidin, PhD. Good morning, Dr. Zainal.
Good morning.
Okay, thank you for joining us in this conference. Before we begin, allow me to briefly introduce our speaker by reading his curriculum vitae. His full name is Zainal Abidin, PhD. Is a lecturer at Computer Science Department, Faculty of Mathematics and Natural Sciences, Universitas Negeri Semarang, Indonesia. He got PhD degree at Information Technology, Masih University, New Zealand, and then master degree from Gajah Mada University, Indonesia, and bachelor degree from Universitas Negeri Semarang, Indonesia. Now he becomes executive expert staff of Rector UNES for Merdeka Belajar Kampus Merdeka or Emancipated Learning. And he has many publications that had been published in many reputable journals. Okay, how are you, Dr. Zainal?
Good, thank you.
Okay.
Arif.
Yeah, thank you for joining us in this conference. We are pleased to have you here. Now he will present the topic, Emerging Technologies in Transforming Education Experience, the Lens of a Future Studies Approach. Okay, Dr. Zainal, you have 25 minutes to deliver your presentation, and the time is yours.
Well, thank you, Arif, for your kind introductions. Good morning, everyone. It is an honor for me to be here as a speaker at the second plenary sessions, along with all respected speakers. So let me open this presentation by saying Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to say thank you to the committee for inviting me to talk here, to share knowledge about what I have done and experience regarding the use of technology for teaching and learnings. I'm Zainal Abidin. I do hope that my slide presentation will give you additional insight about the future of technology in education and will give you benefit for your future academic journey in integrating the emerging technology to support your teaching and learning activities. When considering the impact of emerging technology, it is changing the way teacher or educator teach, changing the way we communicate and the students learns, and also lead to think of new pedagogy. However, this of course draw attention to the challenge of determining appropriate pedagogy to align with rapidly emerging technologies. With the rapid growth of emerging learning technologies such as information communication technology or ICT, and then e-learnings, and then virtual reality, augmented reality, mobile devices, and Internet of Things, and so on and so forth. I think all these emerging technology give great opportunities to us. So the great opportunities are coming to truly enhance education's experiences. So this is the outline of my presentation today. So the first, I'm going to give you an introduction about the emerging technology. And then the second one is emerging technology in educational, and also transforming teaching and learning with technologies and transforming learning environments. So what emerging technology is? Emerging technology is a term generally used to describe a new technology, but it may also refer to the continuing developments of an existing technology. The term commonly refers to technology that are currently developing or that are expected to be available within the next 5 to 10 years. And it is usually reserved for technology that are creating or expected to create significant social or economic effects. So a range of emerging technology are forecast to change and improve many fundamental tasks and interaction in the coming years, including how we work, how we travel, how we communicate with others. Here are the several technologies that support education. I think the previous speakers already mentioned about this technology, so maybe I will give another perspective about the use of this technology in education. So some emerging technology in education, which are cloud computing, and then Internet of Things, artificial intelligence, augmented reality and virtual reality, robotics, and also learning analytics. Actually, there are so many the emerging technology, or what do you call that, like?
Dr. Zainal, sorry to interrupt. Do you have
Yes.
PowerPoint to share?
Oh, my apologies.
Okay.
My apologies that I haven't shared my slide before. So
Okay, thank you.
Okay, so maybe I will give what do you call that, like short introduction about the outlines. So this is the outlines of my talk today. So the first one, I'm going to talk about the introduction to emerging technology, and then emerging technology in educational, and then transforming teaching and learning with technologies, and transforming learning environments. Okay. And we already come up in this part. This is the several technology that I already mentioned before. We will break down one by one. So now we are talking about cloud computing. Cloud computing, teaching and learning are no longer confined to textbooks and classroom, and now reaches computer and mobile devices. Today, learners are always connected, whether they are on or off school or campus grounds. Students and educators or lecturers can use, for example, web-based tool to collaborate online. And here, a key advantage of cloud computing is it reduces the need for in-house investments in hardware and software. This is a major benefit. I think this is a major benefit where cash and other resources are constraints. The next technology is Internet of Things, or we call IoT, or events. Now we have another terms, Internet of Everything. So not only things, but everything. So IoT has become one of the most important technology nowadays. We can connect everyday objects, for example, televisions, air conditionings, our lamps, and many other electronic devices to with the internet via embedded devices. And also using IoT, we can have a seamless communication. So seamless communication is possible between people, process, and things. This is the cyber school system. So this picture is cyber school system with IoT looks like. So this is the picture of the future school enhanced by IoT. So using IoT enabled to develop what we call here a smart school office, and then smart school transportations, and then we have smart school building management, smart student health, smart classroom, smart STEM lab, smart cafeteria, student tracking and monitoring student activities. All the data resulted from either the academic or non-academic activities are stored and processed to monitor the student performance and their activities during school hours. The next is artificial intelligence. I know you already knew about this technology. AI has already been applied to education primarily in some tools that have developed skills and testing system as AI, because as AI educational giving educational solutions. Now AI continue to mature. The hope is that AI can help what do you call that fill needs gaps in learnings and teaching, and allow school and teachers to do more than ever before. AI tool mostly comply with three basic principles: learnings, which is acquiring and processing the new experience, creating new behaviors models, and then the second one is self-corrections, which is refining the algorithm to ensure the most accurate results, and then the last one is reasonings, which is picking up the specific algorithm to resolve a specific task for our daily activities. So three basic principles are presented in four basic form, as you can see in the screens. The first one is assisted intelligence. So AI systems that assist human in making decisions or taking actions. Hardwire system that do not learn from their interaction. So this is how AI help people to perform a task faster and better. And the next one is automated intelligence or automations. Automation of manual and cognitive tasks that are either routine or maybe non-routine. This does not involve new ways of doing things. It automates existing tasks. And then augmented intelligence. So AI system that augment human decision making and continuously learn from their interaction with humans and the environments. This AI helping people to make better decisions. The next one is autonomous intelligence. So AI system can adapt to different situations and can act autonomously without human assistance. So this is like a automation decision-making process without human interventions. As human and machine collaborate more closely and AI innovations, what we call that, like come out of the research lab and into the mainstreams, the transformational possibilities are staggering. The next technology is augmented reality and also virtual reality. AR and VR hold great potential in revolutioning the world of educations. Here, school can harness the potential or their potential to make learning better than ever. So augmented reality is an interactive 3D experience that combines a view of the real world with computer-generated elements. The next one is virtual reality. As you can see here, the children's wearing like Oculus or maybe shutter glasses. So virtual reality is completely self-contained computer environments. Usually to run the virtual reality program, the user must wear shutter glasses or maybe a head-mounted display. This gives a stereoscopic view of the object. So because the right image of the object enter to the right eye and the left image enter to the left eye. Okay, still talking with AR and VR. So Edgar Dale, an American educator, developed the cone of experience during 1960, if I'm not mistaken. According to the cone of experience or the learning pyramid, the learners retain more, what do you call that? Learners retain more knowledge and information by what they do rather than what they read, hear, or maybe observe. So Edgar Dale said that we remember 90% of what we do and only 10% of what we read. So using augmented reality and virtual reality enable us to promote experiential learning by providing school with highly engaging, interesting, and comprehensive, immersive learning experience that can, what we call that, can be controlled and managed within the classroom. Using AR and VR makes the teaching and learning process more interactive and fun. The next one is robotics. What is robotics? Robotics is the specialized type of engineering that deal with the designs, constructions, and operation of robots. A robot can perform work or other actions normally performed by humans. Why robots? A study conducted by Barak and Zadok identified that students involved in Robotic activities often utilize heuristics in the classrooms. Heuristics means the process in which the students act as a problem solvers. So they identify solution methods based on their own life experiences. And the heuristic used by students enable them to strengthen and expand their real world problem and to solve, or to what you call that, like to enhance their solving capabilities. The robot can be used as a learning tool. It can be a mean of making math or science problems, and the students are asked to solve the problem, or maybe the robot itself is used as a tool to find solutions to given problems. So the robot is programmed in such a way that it can do the job what we wanted. Robotic actually can be integrated in a classroom in engaging way to motivate the student in their process of learnings. This is one of my research that I promote the use of robotic for promoting STEM educations. And I know that Prof. Cherping Lim is already explained about how the robotic is used to promote the STEM or STEM educations. So STEM education can be enhanced with educational robotic platform. We can use what we call that, like low-cost educational robotic platforms. So the robot would be affordable to the school or maybe the students. We can adapt if we use robotic as a platform to support teaching and learning activities. We can adapt the system of model for developing sequences of structurally related STEM learning activities by Chalmers and Nations. Here we have the process, the preliminary activities. So here the student familiarize with the context of a robotic constructions task. So familiarizing a student with the context of a task can be achieved by what we call that, like providing students with background informations via maybe short articles or web page or maybe video clips. Or you can, what do you call it, directly give like a workshop, or give directly give them what do you call that, like assembling the robot together. The next one is robot design activity. So here in this stage, the students are engaged in the process of designing and constructing a robot. So they construct the robot, they design the robot. After the robot is designed, after the robot is constructed, they need to have idea. So as a teacher, we need to explore, we need to give like help to the students so that the big idea is come out. So in our study, this activity include identifying topic to be taught using robots. So for example, the teachers must identify the specific topic that can be or can relevant be delivered using the robot. So students were given opportunity to share their ideas to other students and our research group. If we can give like problems to the students so that the students can, what we call that, like construct their knowledge. They able to express the idea. So how the robot is will be used to solve the given problems. So there is any discussions in this stage. So the students and the teacher have a discussion, so that the teacher may be giving a feedback to the students, and then giving a recommendation to redesign, for example, if they need to expand or they need to extend the idea. So, and the next one is the primary goal of robot adaptation activity is this state is to have students deal with a robotic problem. So this activity is about refining the robot design based on big idea exploration activities. And the last one is synthesizing discussion are conducted during the concluding phase of sequence of learning activities. So this discussion provide like a closure and have students go beyond thinking with a foreground big ideas. The next emerging technology is learning analytics. So learning is, if we're talking about learning is very broad process and require efficient tracking and analyzing to better understand results. As an emerging technology, learning analytics is now being used by teachers to better record the learning behavior of the students. So learning analytics is the measurements, collections, analysis, and reporting of data about learners and their context for purposes of understanding and improving learning outcome. According to Campbell and Oblinger's, an analysis process has 5 steps. The first one is capturing. Data is captured and collected in real time from different courses, like from virtual learning environment, or maybe from learning management systems, or maybe from personal learning environments, web portal, or maybe forum, chat, or rooms, and combined with student informations. The next one is reporting. So the collected data is used to generate accurate model for identifying and measuring the student progress. And after the data is collected and reported, we can make predicting. So in this state, the data is used to identify a predictor for student success, outcome, and for identifying risk students. It is used for decision making about courses and resource allocation, which then is used by the decision makers of the institutions. Okay, after predicting the results, we can make actions or acting. So the information gained from the data analysis process is used to set appropriate interventions. For example, teaching or supporting students who are at risk or failure or drop out. So before the student drop out, we can give like approachments to make sure what is actually happened to them, whether they have personal problem or they have difficulty in understanding the concept that delivered by the teachers. And the last one is refining. The gather information is used in a cyclical process for continuous improvement of the use model in teaching and learning. This is the cycle of learning analytics introduced by Halil and Ebner. So there are some steps how the learning analytics is processed. First is generation of data. So this process starts from the learning environment where different stakeholders, it can be learners and then instructor, researcher, or even educational institutions result in, for example, in MOOC, LMS, or any other virtual learning environments. And then data storage. So learner leave a lot of traceable data behind them. So learners are not just consumer, but also producer of data. And the next one is analysis. So the analytic method seeks to discover hidden pattern inside educational data sets. So analytic techniques are various. The authors define them mainly, what do you call that, like into quantitative and qualitative analysis method. So we can use both of approach. I mean the quantitative and the qualitative methods. And the next one is ACT, which means the analysis outcome should be interpreted to actions. In this stage, action is considered as predictions, interventions, recommendations, personalization, and also reflections. At the end, the life cycle loop is closed by introducing optimizations. This is the important things. So the optimization process, which is optimizing learning environment and stakeholders. So there are two, not only the user, but also the environments. We move on to how to transforming the learning environment after we discuss about some emerging technologies. Talking about transforming the learning environment, we need to consider some things which are rethinking learners and teachers' role. It is because that the younger generation is more likely digitally literate than us or their teachers, because increasing information is available online. And I think there is no need to teach students to memorizing facts, instead addressing learning as a constructive activity where the student can create knowledge by interacting with tools and resources. And also educator's role is being more of a guide or maybe mentor, so enabling a more personal learning experience as opposed to be just a source of knowledge. So teachers or lecturer is not the only knowledge resources for the students. So because the students can get access about the informations from the internet or the other sources. Educator guide the learner.
Dr. Zainal, sorry for interrupting. 2 minutes
Yes.
left. Okay.
Okay, thank you.
Thank you.
So the educator guide the learner how to access and evaluate informations and empower students to think critically, behave safely, participate responsibly, and harness the full potential of technology for learning in our digital world. So here the student and teachers need to develop responsibilities and rights as creator in the online space where they consume, create, and share informations. Then the next one is adaptive learning tool, either in content and assessment. So adaptive learning here is data-driven approach to instructions and remediations, adjusting to the student demonstrated performance to provide content and learning resources. So it is more personalized, technology-enabled, data-driven approach to teaching and learning as measured by student engagements, persistence, and outcome. So with adaptive learning tool, students are able to track their own learning, which help them develop self-monitoring skill and fully engaged in their learning process. So although some teachers are being forced to use online grading tool and devices, analysis tools are becoming more precise nowadays. Okay, the last one is open educational resources and massive open online courses. Concepts associated with new strategies in education movement are open educational resources, or we call it OER, and massive open online courses, or MOOC. They are freely accessible resource and can be reused, reversed, remixed, and redistributed. Using OER and OOC, we we can implement what we call blended learning. It is a combination of face-to-face and online learning and teaching. It is benefit student learning and achievement by providing flexible options, I think. And then recommendation for online learning, for example, specific schedule for teacher presence, and then timely teacher feedbacks, varied assessment, or maybe a collaborative work, and so on and so forth. So, and also mobile learning. So an advantage to using a mobile device compared to other technology is the likelihood that these devices are already familiar to the students because of their portability maybe, or maybe flexibility and intuitive interface mobiles, or all those potential gaining increased interest in school, and also growing number of them have turned to maybe tablet because it's cost-effective strategy for one-to-one learnings. In summary, an emergent pedagogy approach that has the potential to prepare teachers and learners to interact and flourish within a radically reconfigured learning space that lean on the aforementioned technology to support transition within and beyond the school and its connected communities. And then with the rise of digital technology in the classroom, it becomes easier for teachers to personalize their lessons, their instruction, and also their project for the students. And also both students and teachers need to develop responsibility in the online space where they consume, create, and share informations. I think that's all my presentations today. Thank you very much. Back to you, Pak Arif.
Yeah, thank you very much, Dr. Zainal, for the very informative and interesting presentations. Now we come to Q&A sessions. I would like to invite questions from the audience. You can ask directly by pressing the button raise hand, and we will give you a chance to deliver your question directly. We have Puput Surya. Puput Surya. Okay, you can ask directly to the speakers. Okay, time is yours.
Okay, thank you. Do you hear my voice? Sorry?
Yes.
Okay, thank you very much. Let me introduce myself. My name is Puput Surya. I'm from doctoral students, Universitas Negeri Semarang, Mathematics Education. Okay, thanks for the time. This question is for Mr. Zainal Abidin about the learning analytic cycle that just now presented. I have a question for you. The learning analytic cycle, this is new to me and have never used it for my research. Just now I have resumed that learning analytic cycle almost same with class action research. Maybe Mr. Zainal Abidin can describe to me about because I can say like that based on my resume, both of them, yeah, learning analytic cycle and class action research both have the same cycle. Can you describe to me about the differences both of them, and can you describe to me how to implement learning analytic cycle in our learning process like that, especially for student university? Thank you very much.
Okay, Dr. Zainal Abidin, please give your response.
Okay, thank you. So, is it different between classroom action research and also learning analytic cycles? So this is, I think, this is different, what do you call that, different context. So classroom action research may be one of the approach of the research. There are some stages if you want to use the method For example, you have to plan, do, and then make actions and reflections, and then you make a planning again, and so on and so forth. So there is a cycle in there. But a cycle in the learning analytic is the process how the data is produced by the student or even teachers in the process of teaching and learning activities is process. So I think those classroom action research and then learning analytics cycle is different. Maybe the term is, they said the similar terms, like here we have, wait a minute, process, interpret, optimize, and learners. And there is a data inside how the data is processed. So for example, here, from learning environment, we got many information, we got many data, not only from the learners, but also from the instructor, researcher, and educational institutions. All the data here is stored in storage, maybe, because we have a massive data, we call it big data, and then big data is processed using data analytic. Data analytic is more than statistics. It's not just descriptive statistic or just parametric or non-parametric statistic, but there is a combination between machine learning or what do you call that, like some concept about artificial intelligence used in this process of analytics. And then from the process, we got the output, and from the output we can giving interpretation. So we can give like what we call that, like interpretations, interventions, and predictions. What we need to do by having the outcome of the data analytics, and then continue against we may be refining, redesigning the process. I think that's my answers.
Okay, thank you very much, Dr. Zainal Abidin. I hope it can answering Bu Puput Surya question. Okay, from the chat box, I have one question for Dr. Syafiq Asmi. This question from Ahmad Bayu Aryawan from the Postgraduate of Animal Science Master Program Halu Oleo University Kendari Southeast Sulawesi in Indonesia. What is the impact of irradiation to decrease cholesterol and lipid on obesity genetic? Yeah, it's fulfill the gut microbiomes or nutrient maybe. Sukron wa jazakallah khair. Okay, Dr. Syafiq Asmi. Okay. Please give your response.
All right, thank you, Dr. Arif, and also for the question. So basically, if we're talking about the UV irradiation, I believe that is more into like will affect the nutrients of the cholesterol itself. And yes, there are a few studies showing that UV irradiation could actually reduce cholesterol, triglycerides, and everything. But in order for us, for me to, or for anyone to see the causation effects on the gut microbiome, we need to study using animal models or human studies. So and I think I think if we have someone from the food background in the food biotechnology, maybe they can answer this in more details. But I always believe that it's more into nutrient first. But then we can explore whether it has impact on the composition of the gut microbiota and how gut microbiota react towards the irradiated cholesterol diet and so on. That's my feedback response so far, Dr. Arif. I hope it helps somehow.
Okay, thank you very much, Dr. Safik Asmi. Actually, we have question for Professor Kenya Simizu, but seems he already left this Zoom, and he texted me if you have any question related with the problem solving and also using of the video clip, you can send him an email to kinyas@hiroshima.u.ac.jp. Okay, and we still have one question from Dian Triwianti to Dr. Zainal. Recently, there is a trending research topic regarding human-centered AI, which is a novel field of research that is striving towards designing system for best serving humans. In your opinion, does a case like pandemic still related to human-centered AI research? If the pandemic is over, could this research still continue? Okay, please, Dr. Zainal, give your response.
Okay, thank you. Well, in my opinions, to respond to Dian Triwianti question is, as long as the AI concept is applied into the research as an approach, it is can be considered as human-centered AI research. Yes, you can continue the research. So because in my opinion, the good research is when we can, what do you call that, like transfers the research into the other context, maybe to the similar context, or even you can, what do you call that, make extensions about your research if the situation or the setting of the research is changes. So I think you still can continue the research even when the pandemic is over. So yeah, I think that's my response, Pak Arif.
Okay, thank you, Pak Dr. Zainal. Okay, since we have limited time now, already 12:09, according to the schedule, the question answer will be end in the 12:10. So, Dr. Zainal, thank you for your response. Dr. Safik Asmi also, and Professor Kinyasi Mizu. And ladies and gentlemen, finally we come to the end of this plenary session. I would like to say thanks again for all the presenters for their informative and interesting talk, and to all audience for your participation. Hopefully the presentation will be beneficial for everybody. Please give applause to the speakers and for you all by pressing applause emoticon. Okay, thank you for your attention. Good afternoon, selamat siang. Wassalamualaikum warahmatullahi wabarakatuh. I will give the time back to Master of Ceremony, Miss Stephanie Diah Pamela Sari.
Thank you for all speakers for the remarkable presentation and also the moderator. We would like to share the token of appreciation for Professor Kinya Simizu. For the outstanding presentation. Ladies and gentlemen, before we close this session, we want to thank Director, Dean, speakers for remarkable presentation, organizing committee, and especially all participants for the enthusiasm in contributing in our conference. We would like to inform all parallel speakers to join at each Zoom room as provided by the committee after the end of the plenary session. The URL room is provided in program book. As for all participants, we would like to welcome you to any Zoom room that you are interested in by choosing the URL. For your information, we will be back after a short break. We will see you again before 1 p.m. in the parallel session. Ladies and gentlemen, this is the end of our plenary session. It's been our pleasure to host this event, and I wish you a pleasant day. I apologize if I might deliver inappropriate speech, and we will see you soon in parallel session. Thank you for your participation, and see you in the next ICMSE. Wassalamualaikum warahmatullahi wabarakatuh.